Can people talk to each other? I think so. Hi, Cam. Hello. Evening, Mark. Sean. So, Sean, is this early? Is this good? Carl, hi, Ben. Hi, Daniel.
Just going to say this is not my fault, okay? Part of it is my fault, but not entirely my fault. And yeah, we'll leave it at that. Never blame a lady.
Ladies are never late. Everybody else is simply early.
It's simply early.
Indeed. Welcome to, what is this, the fifth? Is it the fifth in our series? Yeah, I think it is. Yeah. Fifth. We've done domestic, commercial, industrial, and we've done DNO intakes. So what we thought we would start developing and working on some of the more controversial stuff after we've done domestic, commercial, industrial. The DNO one, we will do a part 2 on. That's probably going to have to wait a while, just because of the volume of work and various other stuff that we need to do to give you some quantitative information. Dan is working on a fire alarm one. Mr. Jackson, if you're watching, date please, which would be nice. So I know he's working on it because I've seen all the photos, and that's going to be.
I was on the phone to him yesterday. He's a bit busy. He's quite busy.
I know he is. Bless him. Well, isn't everybody? So what we thought we'd do is we talk about surge, because it's one of them things that everybody's been either arguing about or going to Alexis, and if it's okay to say, even at one point when we started talking about surge, even I was going.
Oh, I mean, I think it's fair to say, even if you just look at the E5 YouTube, it's clearly an area that we are still on a journey of discovery.
What, you mean the fact that we've done 7 hours of podcasts with 2 different manufacturers and we still don't understand it?
Well, this is the point. And so for electricians that go on EICRs and things, they see this box, they see the indicators on it, but what decisions do we have to make? What observations do we have to make? So this is why we've held on to this one, and we've got the lovely Kirsty with us.
We have indeed.
This evening.
Welcome, Kirsty.
Hi, everyone.
Everybody, you should know who Kirsty is. Kirsty, do you want to briefly introduce yourself in case someone doesn't really know who you are? Don't know who that would be, but...
So I am the Technical Director for Surge Protection Devices, biggest surge protection in the country. We were doing surge protection far before it was anything to do with BS 7671, put it that way. And I also to help write the regs on surge protection, so I'm sort of your lady about surge, I think, generally.
It's been known that
probably one of the nerdiest ladies in the industry.
Well, apparently you were known as the lady of JPEL. Actually, no, I just made that up. So
it wouldn't surprise me.
For everyone watching, Kirsty sits on JPEL, so she's contributing to the writing of the regs. Is it panel D that deals with surge?
The weird and wonderful panel, that deals with all the things that nobody else wants to deal with.
Yeah, it's like the rejects club, isn't it, almost? So what we thought we'd do is, as always, we'd remind you, if you're new to the industry, it's a perfectly exciting time to get into the industry, because technology is developing and emerging, and this state of your career, this is the norm for you now. This surge protection is part of the
it's not going to go away, is it?
No, it's never going to go away. And our knowledge and understanding of it has to improve. So for those of us with snow on the mountain, it's really confusing and hard work at times, especially when different manufacturers have different views and ideas and opinions, and we're trying to find that common sense. So for everyone who doesn't know, and hopefully everybody does, we've got 4 codes in the current edition of the wiring regs. If you want to know what past one's done, check out the old ones, the old webinars. C1, immediate danger. I can see it, I can touch it, it will kill me now. Do you think you'll ever get a C1 on a surge protection installation?
I mean, what kind of scenario would you consider that?
We might. Well, we'll get onto that in a minute. We'll get
Okay.
onto that in a minute. C2 potentially dangerous. I always use the term: one thing has to happen, one thing has to fail, and it becomes dangerous, which then effectively.
Again, I'm thinking critical systems. It could be more cause for the need for that kind of protection in that scenario.
Yeah, you could. Again, it's at the judgment of the inspector. C3, it's crap. Improvement required. Label missing. Screw missing, etc. Does it compromise the safety integrity? No. Does it need to be fixed and improved? Yes. And an FI, I always call it the one that I haven't got time for. But then again, the argument is always you must define your extent and limitation clearly. So an FI is I found something and it needs to be investigated further. Without delay is the key words there, by the way. Not, I'll come back in 6 weeks. I need to investigate this further, which is why lots of FIs equals an unsatisfactory report. Still confuses everybody. My favorite GIF, I'm going to use it in every single presentation I ever use, just because I love it.
Why not?
John C. Reilly's Confused Scientist, if you're wondering. And yeah, so Kirsty, can I ask a question? Has anybody ever gone to court yet over a surge protection issue that we know of in the UK, or maybe even abroad?
I'm aware of the surge protection issue. It's happened towards more light systems. But obviously, it's only been very recent that it's been involved in the regs in surge protection. In terms of lightning protection installers, when the lightning protection system is built and the surge protection is put in as part of that, then is then a life safety system. So if that is not installed to standard, then there will be legal action for that.
That's more under instructional 6305, is it? Or similar?
Yeah, exactly.
So not
similar.
Directly through 7671, which is what we are coding with right now.
Well, I think it's worth noting for those who are watching who may be new to their journey in the industry is at some point, courts and judges are always looking for a precedence. In the last webinar, we talked about duty holder and duty of care in and around D&O equipment. Surge protections are fundamentally, as a device, it's going to be part of the bread and butter of selection and erection and protection of an electrical installation. So it's inevitable at some point there will be a precedent set in law, which is when it's that first instance where a judge can say, right, oh, this is a case where there was a duty owed and there was surge protection required and it wasn't. Them kind of cases tend to become quite high profile, I think it's fair to say.
I guess obviously in legacy, though, we've not had enough of these devices installed for us to identify that a lightning strike locally creating a surge, creating equipment failure. But now we have more of these being erected, then you might start to see the ones that don't have them that are now resulting in failure. So there might be more precedents over the coming years where it's evidence that SPDs would have avoided this. That's one of the hardest points is people actually saying, oh, what does the absence of an SPD conclude with? Because sometimes, people don't join the dots when equipment does fail a period of time after an event.
And the trouble is with inspecting, and I use this nice little seesaw picture from the Engineering Council, it's a balance of risk at the end of the day. And that balance of risk has different meanings for different people, from the person ordering the work, the person reading the results 6 months later, the person doing the work, the person wanting to win the work, the person trying to do the remedials afterwards. Everything in work, in the workplace, is a balance of risk. It's all about these terms: duty of care, duty holder, reasonably practical. You can see on the seesaw, C1, C2, it tilts it to a failure state. An FI kind of doesn't help balance it out, but a C3 would be on the other end as possibly acceptable for an EICR. And that's kind of one of the things we need to realize when we're going through and also coding is how are we managing and judging the installation in terms of risk and how we communicate that better. And if you're wondering what I'm dribbling on about, please watch episode 1 of these webinars on domestic, where we do half an hour on this.
You spent a good half an hour talking about this document and the
indeed, and I'm not going to anymore because I want to talk about lightning, because surge protection is all about lightning protection. Lightning, yay!
Can I just jump in and answer the gentleman in the chat, Old Father Watts, about insurance companies? He's pointed out something very, very important. It's actually something I talk about when I do my webinar. He says, I see insurance companies using the absence of surge protection device to get out clause for not paying out. There is actually insurance companies that are now asking for it on the renew to ask if you actually have surge protection installed. So yes, they're definitely going down that line, pay out for electrical damage. So that was a very relevant comment. Thank you very much.
Apologies, I've just seen the chat. I've figured out where to get it
Yeah,
from.
the chat's there. Yeah, they're chatting away.
Sean Mitchell
That's what they
says
do
I'm
in
looking
chat.
CGI'd. So for everyone watching us on YouTube, you're missing 50% of the fun and the engagement on this, because this is us talking as pals and industry peers and colleagues with lots of people who can heckle us in the chat room, which is quite nice. But yeah, right, okay, yeah. So this is one of the, I think this is an apt picture to kind of start this talk off, really, and that's actually down the road. That's Southend Seafront, recently taken this year at the start of the year, and it's some wonderful lightning strikes.
There's been a lot of thunderstorm days lately.
I think the surge protection and lightning protection.
Do you think they're doing it
up?
Do you think there's some kind of
That's
weather balloon up there that's kind of
yeah. They just go in and go, how many have we sold? Turn up the lightning. No, I'm only joking. That's a joke. A very poor one at that. But
definitely turn it off. I hate the rain. I definitely turn off the lightning.
But so with lightning protection, most electricians, and we've seen it at the Alex shows, I think it's fair to say, is a lot of electricians immediately go, right, so a surge protection device is because of a lightning bolt. And we actually saw that at Ali Pali, where we were packed on both days, where the basic question was, this is something to do with lightning, but I don't know what.
yeah.
And we looked at the regs book, the blue book, and we were like, that really could be a lot better. Probably worth noting, Kirsty wasn't, I don't think you were on JPEL when the 18th was published, to be clear.
No, I think I joined JPEL because of how bad the 18th was.
Okay, there we go.
I've said it before, it's one of my biggest...
Let's hope this better next.
Okay.
I've said it a few times. One of my biggest frustrations is that we illustrate the need for SPDs with lightning, because obviously it's one of the causes, but a lot of electricians will go, well, lightning protection is outside of my remit. And so that's where SPDs have been going for many years now, is electricians have been going, oh, that's regarding lightning, because they look at SPDs, they see lightning, and they disconnect. It's like same thing I have with issues with arc flash protection. You search for that, and they're showing you HV stations with huge amounts of arc flash incident energy, when we need to be thinking about it even at the very low voltage end of the scale. And it's the same here. And this is one of the issues that we have with always illustrating SPDs with lightning.
Yeah, I'd agree with that.
It's something that really, really annoys me.
Just
on something that annoys me. I mean, lightning is an issue, but there is so much more outside of lightning. And you're right, electricians see the lightning thing and then they shut off to everything else.
They do indeed.
Yeah, that was a deliberately leading photo, by the way. There is a question in the chat which has completely disappeared.
Loads of questions, actually.
Which was, and I think it'd be a good one to ask her, actually, because where's it gone?
A lot of people have met you, Kirsty.
Yes.
Alex says you send him emails all the time. So, met you at Nappet Road shows, Alex exhibitions, and all sorts. So, yeah.
Is overvoltage protection...
That's nice.
Sorry, I'm reading out loud.
Yep.
Is overvoltage protection by transients mentioned in the EAWR? So I'm gonna do some number throwing now. Regulation 5, strength and capability of electrical equipment.
It's just another phenomenon of the utilization of electrical systems, isn't it?
Mm-hmm. Yeah, it's quite interesting though. Regulation, yeah. Do you know what? I actually do think now, I'm of that view that I think EAWR could do with a minor update to maybe...
No,
I'm not talking about a full revision, but even the guidance to maybe talk about the connected technologies and the need to protect from external influences a little bit more.
They can just reprint us a Sparks read them and thing.
Yeah, that would help. Adverse regulation 6 or hazardous environments.
We asked about C1s earlier on. A couple of guys did say, well, what about hospitals, as mentioned there, or fire alarms, emergency lighting systems? They're thinking that might be a case for a C1.
Ooh, so this is where, okay. So these debates are going to start to lead away from which is a beautiful thing. But let's crack on with it. So this photo was sent to us a while ago. I think it's on our Instagram page. I'm pretty sure it is. This was one where it was a HV line that had fallen down onto a pole-mounted LV line.
So it wasn't lightning; it was a storm, wasn't it? And it was a line.
It was a storm, yes.
Yeah, it was just a storm.
But it was a HV fault that had basically connected into the LV and sent a big old gush of HV down and absolutely destroyed this installation. As you can pretty much see, it's they're lucky. they're lucky that it didn't do more damage. I'm actually surprised it's still screwed to the wall. Probably used panhead screws in old fact. There's probably an old school spark there, but yeah, I'm still surprised. So this is kind of some of the effects that you can get from voltage spikes that appear in your installation. It shouldn't be there, and this was the best one for me because it wasn't atmospheric origin, it wasn't a direct strike, it wasn't a stroke. This was from an incident that happened outside the consumer's installation. So it's a really good way of demonstrating. Think big, think slightly bigger than the pictures that we try and weave to explain stuff to ourselves. This is another installation which was caused by a strike, strike to the building, and completely blew and melted that main switch quite nicely. In fact, I think I've got a head-on picture. There you go. Poor old Hager board there's had the main switch completely blown apart.
And this is just too much energy. Is that correct?
Yeah. Yeah.
Into the system.
Yeah. This is a perfect example of a Hager board. If there was an SPD in that could have prevented a lot of damage, or if there was an SPD.
So, I mean, right now we're kind of assessing risk to determine whether we need or do not need this.
Mm-hmm.
If this happens in a domestic for electrician, let's say you're an electrician, you've got insurance.
Mm-hmm.
This happens. You assessed risk, or maybe you decided you didn't need it. This has happened. Now, going on this insurance kind of, having to have it the next time, do you think that as an electrician, you should then just install them from now on to give your work warranties?
If you go
or find another insurer?
Go back to the balance of cost and risk, I would. I think it's fairly evident globally that the climate change is impacting. Let's be honest about it. In the last 2 years, we've had more lightning strikes than I can ever remember. We weren't a country for lightning storms. When I was a child, lightning was this rare entity that I would dive under my sheets maybe once or twice a year because I was scared of it. Now, the minute it's, stormy season, autumn, winter, or even spring, it's, the games are even during the summer, for God's sake. We had some a couple of weeks ago that was rumbling through the skies during the middle of the day. You couldn't even see it, but you could still hear that thunder cascading across the top of the clouds. So there's evidently atmospheric changes from global warming that are and should be changing the way we think about how we protect installations. And I think the proof is there's more people putting pictures out there of failed surge protections.
Yeah, in terms of the cost of it, certainly for domestic, and I've said this before, basically you don't really have any reason not to fit one because the cost of fitting it is minimal in terms of installing a new consumer unit or doing a rewire or whatever else. And even if you do that risk assessment, which we'll look at later in this thing anyhow, just bear in mind that risk assessment is only for things of atmospheric origin. It doesn't cover things like where the high voltage cable fell down in that previous slide, and it doesn't cover things that are just generated on the actual power network itself anyhow.
Yeah, it's only based on lightning, isn't it?
So I think we should definitely go along the route, certainly for domestic ones, that it's going to be a standard item that you put in, regardless of whether there's risk assessments done or not, or whatever else it says, because as we've seen there, if you could have done risk assessment on that, it would say, oh yeah, I don't need it. And then there you are, that high voltage cable falls down and there's your result. So
I think that's a win on that one.
And then be a bit controversial.
Go on in.
So when we're talking about the risk assessment, in terms of the wiring regs, the risk assessment is actually not valid for a domestic situation.
Ooh.
At all.
Oh, so that's even better.
Because we have, so we have our, as I know we're going to go through the regs shortly, but we have our situations where SPD must be installed. We have our line about single dwellings, and then it says for all other cases a risk assessment should be performed. If it's not performed, surge protection should be installed. So it's actually for all other cases. It's a full item. It doesn't actually cover domestic scenarios.
Interesting.
What's your take on its current approach to dwelling units as it's written?
I think it is possibly, which is saying something, the worst written regulation in 7671 history.
Wow.
I think it's so open to interpretation, and it frightens electricians because they don't quite know what to do with it. Yeah, I mean, I think...
Sorry, go on.
single dwelling units, it may be omitted. Surge protection may be omitted for single dwelling units. Total value of the installation equipment therein does not justify protection. I mean, for one, they could actually start speaking in proper English, and so people could read it and understand it. But secondly, to that, it's so ambiguous. I mean, as an electrician, you can't walk around somebody's house and try and add up how much their house is worth, because they'll think you're trying to rob them.
So is the point of that regulation being worded in such a stupid fashion just to make a gradual change in approach? So instead of going, we don't really mention it, to now you must, we're going to go in the middle first, and then increase that over a future amendment, maybe.
I think European regs, obviously we take our regs from European regs. What the European regs say is SPD must be unless the value of the electrical installation is less than 5 times. So they give you a physical value. So if an SPD was 50 quid, your installation would have to have the electrical value of less than 50 quid, less than 250 quid to not install it. When it came over to the UK, they watered it down and made it much more messy. And my professional point of view from the company, and not as anything to do with JPAL, I feel that was to appease certain other members of the, rather than the technical intent of what the European regulations were actually talking about.
So just on that, there was a question, somebody asked what JPAL was. So JPAL is the Joint Power and Electrical Committee. They're the UK group that try and interpret the harmonised documents of Europe and agree what we're going to put in 7671. And
yeah,
there's lots of committees.
Tea, biscuits.
Yeah,
Standardization meetings.
Yeah,
emails.
really complex wording, like why don't we use the word equipotential instead of equal voltage? Really?
And then debates.
Yeah, let's sound intelligent.
It's you can do some of your own work. I mean, we looked at 603, 604 to kind of then look further afield. But yeah, I have nothing nice to say. I'm sorry.
Right, can I just interject here?
There are some people involved in JPAL that genuinely, like I'm involved with JPAL because I want to make a good change within. Not all don't tar us all with the same brush.
Oh no, we would never do that.
But we're familiar with some old people who are just they need to
retire, I think is the phrase. Yes. And there should be a time limit.
Basically stopping things moving forward, like the way you want things to move. We know many that are just obstructing that from happening.
The value thing, I mean, whether it's £50 or £100, or even if it's like it costs you £500 to put the thing in, the reality is that 99% of people are going to have way more than that in their house. And even if they didn't, the other thing to consider is that the consumer unit itself is not a 50 quid item, or it certainly shouldn't be.
No.
If you've got like an RCBO board and it's got like 10 of them in it, I mean, you could be looking hundreds and hundreds of pounds just for the consumer unit. So straight away you're over the value anyhow, just for the actual consumer unit itself before you've actually connected anything. Yeah. So yeah, the whole value thing, and you can exclude it, is a complete load of nonsense. Certainly for any installation.
MK have got some a screw fixer knocking out MK boards at 66 quid.
Yes.
Close to the 50.
But I think this is the frustration though. The frustration is where we have such a lack of understanding in the actual technology itself, and then we have that regulation, then we look at how we apply these, where we listen to the common person schemes to give us instruction, and then they give us mixed information. It just creates a load of noise and a load of confusion and differences of opinion, instead of just giving it a
Wouldn't it be good if we could have differences of facts instead of opinions? That would be good. And technical
I mean, like how a risk assessment would work. If it's this, do that. If it's that, do this.
But technical opinions based on evidence and experimentation and advice from scientists and various other people. And oh wow, the world would be a wonderful place. Can I just say that Cinnamon here has put the best comment I've seen on any of these webinars. Yeah, Cinnamon. I believe that's how you pronounce it, or I'm reading it. He's written, Serge, would you like a little lemon twist for that? Which I love, because that's Beverly Hills Cop reference to the guy Serge.
Serge.
Serge. Anyway,
Serge.
Yeah.
Yeah.
Very
I'm
good.
actually 60 messages behind. I need to catch up.
I know. I'm just reading through as quickly as we can. Actually, just moving on into this. So here's a code. Let's do some coding. So you are now walking into a building that is an electronic systems protection first surge protection device. Hopefully, I've got this working right. So there you go. Just in case you can't see much, code that. So what do you think? You've seen that. How would you code it?
Shall I run a poll?
Run a poll. Old Father Watts. Is your dad in this somewhere?
He's in all these. He's supposed to be doing
Old
work.
Father Watts.
Yeah. Stalks me.
I can see insurance companies using the absence of surge protection as a get out clause if there's inambiguous. You know the word I'm talking about.
Yeah, Kirsty read it out earlier.
Yeah, yeah, that's definitely a weird one. Insurance companies, any levels of no, I am well behind.
But you
Not
mentioned a
allowed to vote. That's mean.
But you mentioned a precedent, and this is the point. You know, if there's a precedent, then they'll go, "Oh, have surge next time," and if you don't have surge, then you're in trouble.
Confession time here. Shauna said, "I live near Southend, never seen that." That's because you were experimenting with AFDDs at the time that photo was taken, because Sean is very near that. Yeah. Oh, look at that. James has already put a comment from EAWIH. Reg 5, paragraph 82. These currents include, for example, low currents, transient overloads, fault currents, pulses. There you go.
There you go.
Reg, see, I was right. Reg 5. There, I didn't even get the book out.
Chaps, that must be from HSR 25.
Yes.
He's giving you a chapter paragraph number.
Yes, yeah.
Good man.
Oh, he said Paul beat me to it. Sorry, I've just literally read your comments, so this makes no sense to anyone watching on YouTube, but there you go. We are trying to go through these comments, do their job. So what do we? Is everybody coded?
I'll give it a 71% have voted. So let's and then share this one.
So this has been C2 potential danger.
57% have gone C2.
So question for everyone in the chat room then: what and why would you say that there's potential danger there? Because these devices are designed to take a pounding. No surge protection device just goes, and I'm dead. Well, unless there's some apocalyptic event maybe, or they're just poorly made. John, you can vouch for that. But why? What are we looking for when we're coding that?
Well, Daniel Casey's put a thing in the chat there as well. Put FI as in, what is it protecting? Is it a safety critical service? So it's not just about the thing itself, it's about what it's actually attached to, which obviously in this picture we don't know. I'm sure we can guess, but obviously you'd need to consider it in context of why it's been fitted in the first place.
Yeah, no, I agree. So it's a three-phase system. I can tell you now, I know this one because this was the one for, I think it was Thorpe Bay. That was a surge protection device for Thorpe. Oh, no, it wasn't. Thorpe Bay comes up in a second. This was for Raynham.
Because I can remember one where it was like this as well, and it wasn't that one.
Yeah, well, no, we've got another one. But right. Yeah, I would see to this because it's three-phase. It's obviously, if it's three-phase, generally it's not going to be domestic. I hate using that word generally, but it's not going to be domestic. When you're there, you're going to realize if there's a commercial operation, interruption or damage to electrical systems interfere with commercial operation, which has a potential commercial risk to the business, and damage to cabling and electrical infrastructure is so high that there is a potential danger to the operations of the business. More importantly,
does that warrant us going into C2 territory, though?
Yeah, I would say so.
And do you want me to give me insight from my point of view on this?
Yeah, go for it.
Go for it.
So from my point of view, I know, obviously, in the industry, I know this device, so I know straight away looking at this is a type 1 lightning protection device. This isn't just designed for your standard surges, so this will be attached to a structure that had an external lightning protection system on it. So straight away on an external lightning protection system, your surge protection device isn't running at full strength. I mean, if you get a lightning strike to that installation, you're probably going to have severe damage, and then there is a risk to life. So from my point of view, it would be C2.
Yeah.
Smart ass.
I'm C2, and also at the top she knows her stuff. At the top of the device, there's a volt-free contact, which allows you to do some sort of remote indication, which, lo and behold, the lightning protection company that installed it basically would not bother. because it's I don't know how many people have engaged with lightning protection. We spoke about this with Sean from Dane. Was it's we'll do all the cable, the tapes around the outside of the building and the rods, and then we'll just leave a cable cord up, and you get someone called an NIC electrician, whatever that is, and then they have to figure the rest out for themselves, or that's left on the floor of the switch room. But yeah, so I think that's a good example. C2, absolutely. I've got another one for you. So well done everyone who did C2, and well done everyone who did LIM, because not LIM, sorry, FI. I've got LIM in my brain now. That's it. I'm Mr. LIM from now on. Here's another one. It's not exactly the nicest, is it, really, to be honest with you? I've zoomed in. There you go. I figured out how to do zoom in now, by the way, on this. So
good man.
It's labelled up. Surge protection is another one off a railway. What you can probably tell, if I zoom back out, I think there's a number of issues going on here.
Okay. Well, I mean, if we do a poll, it'll be the same thing, won't it?
Let's code it. Let's code it.
You want to code it? Okay.
Yeah, let's code it. But let's see if people maybe before they.
Did you want to say anything else before we launch it?
No. This is the only photo I've got of it. Sadly, obviously you can probably, if you look at the photo, you can see that the armors are rotten where they connect into the board. Okay. But also the one thing I can't see very well is the actual means and method of connection. And I can tell you now that was a sub board. Now there is distances and requirements for distances, and that's again a type 1. So you have to wonder, is there any effectiveness from that device on the length of connections?
All right. Well, okay, we'll run it.
So for me, the length of connections on that, it looks to me like it's bolted to the side of the board on the right hand side. Mm-hmm. So it would depend on the wiring inside, so it would need further investigation. My first thing at that was, it's a 3-phase surge protection device. You've only got 2 lights on it, so your 3rd phase is not connected. If the device had gone, it would be showing red. So that tells me it's got no connection on your 3rd phase. And
this is the deep joy that electricians face, because when I first looked at these, my first comment was crap, because there is crap.
There's crap on it, yeah.
So then I have to go and get a specialist to go and clean said crap off, because a lot of electricians won't use big wipes, and there is hazards from pigeon poo as well if they're breathed in. But yeah, she's absolutely right, because red shows there's a fault, so there is actually some form of disconnection going on there.
Yeah, just on that pigeon thing, yeah, for those that don't know, if you get a lot of pigeon crap and it gets in the air and you breathe it in, it is actually a very serious health hazard. So don't, if you can avoid it, get specialists in to clean it up first.
Can I just say that's the first time John has ever said crap on any form of content. Well done. God bless you. Mm-hmm. Keep it up. It's good to know. I'm going to make a GIF for that or something. I'm just going to put that on loop. Sorry, I'm joking. So yeah, there's definitely FI needed there, isn't there? So what does everyone else think about it?
Obviously,
we can't vote, can we?
No.
Okay, fine.
Let's go. 74% voted, and here we go. 51% have gone C2. 43% on an FI on this.
So the principles of kind of both were the same. There's two of the same devices, 2 different scenarios at 2 different locations, but 2 different codes, even though at first glance you think it may be the same thing. And this is the point of one of the things that we need to do, in my opinion, is we need to look more, we need to study more. As electricians, we know a Hager product, a Schneider product, we have our go-to devices, but I think it's fair to say when we're doing coding, we need to understand these larger devices, the smaller single phase. We're going to have to start looking at various manufacturers as to what their indicators are and how they operate and if they work differently, which I think we'll come on to in a bit anyway.
Yeah, I think generally with majority of electricians, they see an SPD, they know it should be there and the lights should be on. If the lights are either of red color or they're off like this, I'm not sure if they would already immediately know the differences between the two.
Yeah, and sometimes it's as simple as, if I can zoom back in, it's as simple as actually reading green, full protection, green and red, reduced protection, red, no protection.
What about no light?
There's no light, exactly.
My worry, obviously it's a 3-phase panel board, you put a 3 device in. My worry straight away would be you've got a loose cable somewhere, and that potential hazard all by itself.
It's fair to say me and Dave know that pain. We know that pain, trust me. Okay, so this is another one that I've stitched this photo together because this was, you can only see the bottom of the device just because of my crap photography, and I apologize. There is more to this picture, but I wanted to get the key points in. There were no lights on this. So imagine that panel board is off. What would you code no lights? What have we just spoke about? What's the code? What does everyone think the code is?
Want me to do it again?
Yeah, do it again, run it.
Okay.
The solution is kind of staring them straight in the face there. But this is the thing. This is the different, because this one is one that personally bugged the hell out of me, because it was like, well, hang on, there's an evident answer to this, but we didn't realize how evident it was until we actually opened it up.
Right. Is this one the way it was assumed before inspection it was just switched off?
Yes.
Right.
Assumed switched off. But upon closer investigation and more safer working
Switched off, is it?
it's not switched off. No, it's completely frigging disconnected.
If you assume things on any electrical installation, then you're going to get into a load of trouble, because if you assume something is what it is, you'll find that it's not, and it's the one thing you could never have imagined, and that's actually what it is. So
what's the famous term for assume? With assume, you make an arse out of you and me.
Indeed.
Stick the spelling. Yeah. So what does everyone think? Has everybody voted yet?
Yep.
I know it's an obvious one. It's Captain Obvious, but again, it isn't. And this is about sharing the stories of the stuff we find, so that as inspectors we can be better and we can understand that we might not necessarily always think of everything.
We've got a draw on this one.
Oh, do you know what? Both of them are bang on. Oh no, I'm sitting on the fence.
Yeah.
Sorry.
You're two coding.
I'm dual coding. How dare I? Definitely FI was required on the initial discovery of no lights. And for not having that protection, absolutely C2, because it's commercial operation.
And for the benefit of YouTube, it's a C2 and an FI, both got a 41% vote on this one.
Yeah, sorry, we keep forgetting that everyone's watching this on YouTube, so we apologise. It's much more fun inside.
I make it my job to try to say it so that people can then catch it. But yeah,
your job.
So
thank you. So yeah,
why has it been disconnected?
I can actually tell you the reason why it was disconnected. Because it was annoying. Because basically what was happening was it kept on. There was a history of these units failing, and because it was costing people money to replace them, they didn't understand what it did. They just had it disconnected by the electrical contractor. So the electrical contractor didn't know any better.
They kept failing around a route.
Yeah,
this is annoying. Yeah. Let's just take it out.
Yeah.
Genius.
It's genius. But what that does do is that shows you the electrical contractor had zero competence, and it also showed you that the client had zero competence as well in the ownership of this device. And this is where electricians need to be more considerate, better communicating the wording and the discharging the duty of care. And I love the fact that the one of your guys has put paragraph 82 of Regulation 5. You know, you can link these 7671 clauses, however badly written they may be, and that duty of care as a competent contractor to take all reasonable steps to say, I've found a surge protection disconnected. It's realistically a C2. I don't really need to investigate unless you're not opening that panel, then there's an FI. But by the way, this needs to be better protected. Oh, and also I need to understand the levels of protection that device gives, and is it suitable and sufficient for protection of the current system?
Okay, question.
Regulations.
Question then.
Go for it.
I mean, bear in mind that this is probably relative to railway. However, if this is anywhere, this is going to be under lightning protection 62305, correct?
Yes, because it's a type 1, but there are some of these that are type 1.
We had this chat with Sean, and when we talked about car parks, and I said, well, why is 62305 not within the reach of the scope of BS 76710? And this is the same problem here.
Oh, yes, of course. Car parks were they? These big rods.
There is a crossover between the two. So although the that have got an external lightning protection system are outside of the scope of 7671, they refer to 62305 so often that I don't believe it can actually be outside of the scope of 7671.
Don't they put it in the scope in 110?
Because there's too many old people that need to retire.
I'm gonna have to edit this like mad now, you know that. This isn't coming out for weeks, everybody, because I'm just going to have to go through and edit all of these honest comments.
So under 7671, when we look at lightning protection, we think, okay, it's not in scope. It does say in 443 somewhere, many references to 62305. So that means we now have to go and get 62305 and pick up 62305 to realize that that type 1 is actually necessary? Or do we just get enough? Do we get enough from 7671?
You do get enough from 7671. So in the 534 section, we're talking about what sort of devices to put where.
In the selection.
The thing about that one is whoever disconnected that and requests it disconnected, I mean, it's total incompetence, because even if they didn't know what it was for and they've come across this device, the proper thing to do would be to actually go and find out what it was for, rather than just say, oh, we don't need it, let's just get rid of it. Because there's obviously going to be stuff out there, not just surge protection, all kinds of other stuff that people may not have come across before.
The problem is, John,
I don't know what it is. So
how many times have you been on a site and you see old gear, old switch gear that's left?
Yeah.
Yeah.
You know, and an electrician might just assume, oh,
there's that
that's
word
been
again,
left.
isn't it? Assume that it's not needed.
That's been left.
So yeah, make a bit of effort, and let's face it, it doesn't take a huge amount of effort to find out what these things are, does it? I mean, everyone's got the internet now. It's 5 minutes and you can find out. So yeah, make a bit of effort before making just random decisions of getting rid of stuff and thinking it's not actually needed.
So I've got mentions of type 1 SPDs on page 161. Where do I need to go to from there, Kirsty?
So you've got your image on 160 with the lightning zone concept. And it says in the key for that, where you've got your book rings, SPD at LPZ 0 to 1 for lightning current protection. So it says, this little star at the bottom says, boundary of LPZ1 is an external lightning protection system. So it is telling you there about lightning protection devices, and then it starts to go over to type 1 and type 2 on the next page. When we go over to 162, we have a little diagram where we have type 1 or type 2s. And it does talk a little bit more through there. And it's usual with the regs, it isn't the most clear thing in the world.
So is that enough for it to be within the scope of my EICR under 7671?
I would argue yes.
Yeah.
534416, part 3. Overvoltage and other services feeding other structures, such as secondary buildings, external installations, lighting, power lines, and feeding external sensors. I would probably use that one section there to say that the car parks are relevant and prevalent and inherently linked. But yeah, sorry. Just to clarify as well, 62305 is mentioned 27 times in BS 7671, which I find remarkably wonderful and brilliant in every way, shape or form, especially when they then have the cheek to actually talk about it being excluded from scope in 1102. Part 9.
Yeah,
and I have had this chat with people in the nosebleed sections of our industry. There is a bitter irony, and I'm going to say this out loud, a bitter irony and a stupidity in doing an exclusions from scope, where last week we talked about part 1, systems for distribution of electricity to the public. Well, that's the transformer, the cabling, not necessarily the head, because a system is a series of components, not one. So there's not that transparency and clarity in where the boundaries are, and within installations now, everything is becoming so mutually independent. Regulations are now, I think it's fair to say, overlapping each other consistently, or not, as may be the case in some regulations.
What I have in my head, which you guys aren't too familiar with, is the incompetence or the basically the 2391 and other training about this work, and the lack of coverage in this area. It's just frustrating.
I think there's a lot to do.
In the comments, a couple of people put, what are the current transformers for in the picture? Because they don't seem to have any kind of points of being there. They're just
they were once upon a time, I assume, monitoring.
They were at one point doing some monitoring, but they were removed because they were pretty crap.
A lot of those need to be removed. They're in the bloody way in a lot of your stuff.
Indeed.
All right, I'm going to catch up with the chat. I'm 114 messages behind. You guys.
Oh, apologies. Okay, so yes, no for risks. I'm reading the chat as well. So if you're on YouTube, just play some elevator music in the back of your head. Yeah, they're almost as bad. Old Father Watts said almost as bad as premature collapse of wiring systems. The IET needs to start writing in plain, understandable English. I personally have a view, and that is they do it because they want to feel empowered. I have had this debate with a number of people. Some of my views on the use of the term equipotential. I genuinely did not know, because again, born in Tottenham, I didn't know what equipotential was. It was only when my college lecturer said it means equal voltage, and I just said to him, why the hell don't they say that? And he went, because they want to sound important. I was just like, that's just arrogance at the highest level.
It brings us full circle with...
We don't dumb down. We're not dumbing down, but we need plain English so that there isn't that ambiguity or... People
need electricians to need people.
Yes.
And they
also,
they,
David, the most
they need us to not know this stuff.
How do the competent electricians explain this to the public when they're talking about equipotential and transients? Because if I said, oh, equipotential transients, they'd go, equal opportunities for tramps.
I've had a couple of phone calls with a couple of lads like Nigel, etc., where they've asked me how to help them write, because electricians don't want to write technically because they don't want to overwhelm and put nuisance information in front of their client. But they first need to understand the technical detail to then simplify it. You must first understand the technical content to then simplify it correctly, instead of just simplifying horse shit, which is often what happens. Because
that's it. I mean, that's why when that's why I start right at the beginning when I do my surge protection training, and I literally start with how a surge device works and sort of why we're using it. And I think there's so much of that missing.
Yeah, there is.
All the courses that are out there now. I mean, I've written quite a few for various different organisations, and none of them are interested in going in right at the basics of explaining how a device works, why it works the way it does.
So just on this, there's some great comments. Did Boris Johnson write it? It's a terrible regulation. Does anybody in the chat have different explanations that have been given to them that they can share with us as to what a surge protection device does? Because
the majority of people.
One of the ones that I like the most is I was trying to explain it to a plumber, and this guy, because I was showing him some surge protection devices, and he was wiring up my boiler, and he said, "Oh, this surge protection stuff." Oh, and I said, "Well, that's like a £2,000 boiler there. You know, that's critical to heating of my home. I need to make sure there's surge protection." He went, "What's it like?" So I tried to explain it to him, and he just went, "Can you just explain it in water terms?" And I was just like, well, imagine water coming into a device, and if the pressure goes too high, it diverts it off somewhere and blows it out the side of the house. And he went, "Oh, right, yeah, no, I get that. We've got them all the time. You know, on boilers, they have them built in where if there's too much pressure, there's a pressure relief valve, and it just blows the water out to protect the boiler."
Sometimes the water analogy is best. I've been doing it this afternoon, writing some original syllabus, and you have to go back to the water analogy as a way for people to see electricity.
Flow in, flow out. Yeah, flow in, flow out. Too much pressure, all of a sudden, diverts it somewhere else. But with surge protection,
I think
far quicker.
A lot of electricians, when they go on an opportunity to do training, like with regulations training, unfortunately, I think we mentioned this on a previous webinar, the trainers don't have the knowledge to honour it and deliver it to the attendees. And the trainers think about the exam and they go, "Oh, there's only one or two questions, let's move on." And there's no added time to add the information. So there's no time to bring in an understanding on the actual technology to then understand how to use the technology. It's a case of, there's a reg, there's one, let's move on to part 5. And until that gets fixed, a lot of electricians will have to then come back round and they'll have to go to the conferences, exhibitions, and they're still confused. So not enough time.
I mean, I use the water, I use the bath flow analogy. That's my... on how a surge device works and why it does what it does. I think I've never had anyone, when I've explained that, not understand what it is.
I mean, the basic concept is quite simple. And once you get people to understand, obviously, what it's about, but if you go in with all the wrong words, then of course people are never going to get it. But yeah, if you simplify it, it's the concept is quite straightforward.
So for everyone watching or anyone who's learning, MCBs. Yeah, overcurrent and fault current protection, RCDs, earth leakage, surge protection, transient voltages, spikes in voltage. It doesn't deal with current, it deals with voltage spikes, protects the fixed equipment. Doesn't regulate voltage or anything like that. It's that additional protection that we never knew we needed, but evidently we do now. So I've got a controversial thing before we get onto this different way of looking at it. I think when the 18th edition came out, the best intentions was done with the surge protection requirements. I just think it was probably maybe too much or done rushed, because surge protection wasn't new in the 18th edition to an extent, because there was the AQ criteria, if I remember it rightly, in
AQ2.
past editions that we had to consider that nobody bothered doing.
It was negligible, I think it was the external influence of AQ2, which was basically said there was not much.
Great.
And that was it.
You mean like that regulation that says DC in an AC network go to a reg that doesn't exist?
Well, at least there was something, but yeah, AM7's got nothing in it.
Yeah. So what we thought it might be cool is to kind of reverse the whole way of look, because we always start with the regulation. What's the regulation say? So I thought it might be cool if Kirsty, we could maybe look at a calc or a formula and take a random place and work backwards, because we're always working forwards, and I thought it'd just be kind of cool and different to work our way through it backwards, if that makes any sense. So yeah, this is a map, and Kirsty,
Yeah, no problem at all.
go for it.
Okay, so this was, oh, sorry, I hit my mic. This was just on the outskirts of London, and it is just a random building. I don't know what's in it, whatever. It was just a building I want you to use so we could go through the risk assessment. As I said, this is not for a domestic, so this is not a domestic, even though it's obviously huge, it's probably not a domestic. I just wanted something to be able to show you an actual building to do the risk assessment on. So formula, which I know we're going to go through shortly anyway, the CRL, calculated risk level, is what we're trying to work out. We start with the FEMV, which is the factor of the environment, which is given to us on page 103 in your regs. It's just a little table. Rural and suburban environment, you start with a number of 850. I can't remember which one way around it is now. A rural and suburban, sorry, 85, and a urban environment, you start with a number of 850. LP is the overhead and underground cables coming into your installation, and NG is given to us off the grayscale map. So you just pick where you are in the country, gives you a colour corresponds to a key, you pick your number out, and that gives you your NG to put in. So starting with the factor of the environment, this is literally on the outskirts of London, urban environment, so we start with a number of 850. LP, so we've worked it out here. As you can see, coming into this installation, we've got no overheads. So we're only looking at we only take into consideration the nearest kilometre. We don't take into consideration anything over that in terms of the risk assessment. So as we can't see any overheads, we take it as 1 kilometre underground. So we put that into our formula, and we literally end up with LP equals 1. NG, where we are in the map, is 0.8, so we put all that into our CRL. We come out with a number of 1062.5. So as the number is above 1,000, the risk assessment tells us that protection against atmospheric transients is not required.
Yeah.
But what I want to point out straight away here is, even though it's not required, it's only atmospheric transients. This is not talking about surges. This does not tell you do not need surge protection. It just tells you do not need protection against ambience. What do you guys think about that?
Well, I think that's a key wording there, isn't it? So we've spent donkeys going on about these bloody calculations and formulas, and it's that key word. It's protection against atmospheric transients. That necessarily, you know, it's not really surge to the extent of what we are selecting and erecting within our board, especially within a domestic home. I think this is where it's become a mudder's fuddle, if you don't mind me saying, and where the wording probably could have been improved quite a bit.
Yeah. Terry Austin in the comments has found an interesting fact about this building. Apparently,
I knew
this building is a block of flats.
Oh, well, I'm just taking it as a random building.
So, how on earth have you found that?
They found them. They've looked at the road name, and they've Googled it, and they've mapped it. And you know what? Tell us where the nearest sub is, guys. Come on. I knew this had happened. Put a photo in, and they'll find the image of where it is. It's a block of flats. Good on you.
He's probably in one of them.
For me, with this building, it was just a random one. I deliberately did choose it because it backs onto the railway line. So although this risk assessment is saying you do not need protection against atmospheric transients, proper surges, over voltage transients are going to be a major issue backing onto a railway line. So if you have any sort of critical equipment in there, anything that's going to be sensitive, it would be really, really surge protection. But the risk assessment would tell you you don't need it against atmospheric transients. So you have to be very careful with the wording.
Why is that, Paul?
What? The wording?
No, the railway line. What's happening on the railway line to make that a problem for me?
I can't possibly say anything. My lips are sealed. No. So one of the things that can easily happen within that distance, you can get traction return currents easily, given the position of that. If that's a block of flats, one, I would ask who allowed that to be built so close to the railway line. And don't get me wrong, there are loads of them, but one of the things that kind of does the thing with my urine is when you see blocks of flats going up, and it does boil it. But one of the things that they don't do is they don't do the cooperation and coordination principal designer duties between the railways, and they don't realise if that was, say, a third rail or a DC traction system, what you'll find is within that distance of the tracks, if that's within 30 metres, they'll be importing and picking up DC on their rebar and their foundation. Which is a problem, which may end up in their consumer units because somebody will probably put loads of rods in and foundation rods and connected everything together, and there might be a problem there. If it's AC, if there's a dewirement, there could potentially on a dewirement, given the fact that the wire can flay and splay everywhere, what you will end up getting is whatever piece of metal it eventually earths out to, that traction return and that voltage will dissipate into the ground and produce a stroke effect. And if there's a cable nearby, you may end up with current and voltage appearing on that and entering the electrical installation via the stroke, which we'll explain at the end. We've got nice images of the difference between a strike and a stroke to explain to you at the end of this as well.
What kind of proximity would you say would be safe? Let's say, because again, electricians might be in there doing a domestic or a commercial EICR with absolutely no knowledge of electrification.
There is, okay, so here's a bit of knowledge for you. York EMC services do a great EMC in railway training course. I've done it. And they also do a 3-day testing of EMC. And I went there as a simpleton electrician asking lots of questions. And we went into the middle.
Is that where you went into a field in a tent?
We went into a field in a tent.
I've
we had an electrode in the ground, and the guy put an oscilloscope onto it, and he was managing to pick up traction return energy a mile away from York Station, and he was able to literally look at the timetable and go, yeah, that's the 302 from York. And we were still picking up the return energy dissipating in the ground. So I am learning at vast array, as you know, Dave, that true earth is pretty much, it's not 0 volt. It's always going to have some form of charge, voltage or energy in it, unless you're in the middle of a field. And even then you can't guarantee it.
Because again, I mean,
with a lightning stroke, we can travel up to 2 miles underground and cause voltage disturbances up to 2 miles away. So I'd be looking out from your traction return system.
So, and this is why I don't live within a mile of a railway as well.
Okay. I've got a railway about 50 yards from my house. Okay.
Move.
So, question I've got is, how are electricians going to understand this?
Well, I'm going to be honest, I've struggled to understand it all, to be honest with you, in my simpleton brain. But the thing is that, again, this is my opinion, that's okay with me, because every journey you go on is about learning and discovering and using your peers to bounce off. The people in this chat room are making some great comments. Daniel Casey's quoted IEC 60364-4-44 because he's just that detailer. God bless you, Daniel. And he's quoted the reg. Overvoltage protection is not required for a single dwelling unit where the total economic value of the electrical installation to be protected is less than 5 times the economic value of the SPD. Well, the SPDs are priced to always be less, so why are we not doing it everywhere in domestic? But I think, if it's fair to say, there have been lots of, I'm going to go back to my asset management principles, tribes. There are lots of tribes in the electrical industry, and lots of these tribes are commercially driven beasts trying to give the right advice while also being cautious. And it's fair to say, when we first started talking about surge protection in the getting ready for the 18th edition stuff, nobody really quite knew what it was about unless you worked for the Danes or the Kirstys of surge protection, who this is bread and butter. And then to see the wiring regulations maybe poorly worded, and then electricians who need it very simply put on a plate for us to understand and be brilliant, that's where allow it to come in, settle down, people interpret it, understand the nuances of the wordings. I mean, I'm still at this moment reading small paragraphs of wording in the regs and in the AWR that's changed my opinion on stuff. You know what I was talking about the other day with the definition of live in
charged,
and it explicitly removes the word the pen conductor, which I think is very, very deliberate, and you wouldn't notice it unless you were looking for it. So I think this is just one of them things that over time we have to understand and realize. But for a domestic installer, do we need to understand the flash density map? I think an awareness that it's there, yes.
Oh, the flash density map, yes, for lightning, but obviously when you think about the railways as well,
absolutely,
little things like that.
I always look at the railways as a 24/7 storm. To be perfectly frank, so protection against transient voltages is a constant in rail. I think that's fairly evident, to be perfectly frank. I'm sure there's some information that will come out before Christmas on that.
You go back to that picture that Kirsty put together.
Certainly, sorry.
I just wanted to, just for completeness of YouTube and people here, obviously,
Yes.
so Kirsty, you've explained obviously that there's no evidence of overhead lines. So with regards to the risk assessment, you're saying it's all underground, and you're saying it's up to 1,000. Can we just explain where this 1,000, what that's about, please? Sorry, still muted.
I've got some people asking about my math, and I'm pretty sure I'm right. I'm a nerd.
Ignore the people in chat if it comes to math.
Yeah, let me read that because I've just seen 134 messages on my screen.
Just getting back to my regs page, 1 second. So, regs say, let me right.
I agree with some of the chat here. Sorry, Kirsty. I was just going to say, I agree with some of the chat about hiding standards behind paywalls doesn't help, because we are limited in our understanding and knowledge from the industry bodies that give us what they want us to understand. And I think it's fair to say that there was some, when arc fault detection was introduced, there was industry bodies that would stand up at their events and say, yeah, arc fault, you don't need it, in front of the manufacturers. When in actual fact, that's not the professional way to act. The professional way to act is we need to understand the emergence of arc fault technology and where best you can select and erect it to enhance protection for your end client. But we need to understand we now know we need to understand every manufacturer and how they have interpreted the product standard for arc fault. And it's the exact same research. We need to emerge and develop our knowledge so that we can give the best information for electricians, or at least allow them to access it without having to pay 486 quid for a standard. Sorry, Kirsty, over to you.
No problem. I just want to explain my math a little bit here.
Certainly.
So, I have written rural and urban environment and number 850. That was because I was working with a few different images before I used this one. It is actually an urban environment and it is 850, so that is correct. When you go a kilometre, so because we can't see any overheads, it's 1 kilometre concealed. You're putting your 1 in, it's LPCL, so there's no factor for it. So it literally is LP equals 1. The 2 there is that's the factor you use if it's an overhead line. So it's just 1. That's all it is. So when you come through, I think that's what's thrown people, is that 2 there, but that's just a factor that you times it by if it was an overhead line.
No, they need to read the formula in the regulations. The 2 is applied to LPAL.
Yeah, the key there is that it's 2 times LPAL, and LPAL is 0.
There's no LPAL here.
2 times 0 is, of course, 0,
Yeah.
and the same for the others, because the other ones are also 0. So it's 0.4 times 0 and 0.2 times 0. So it's all zeros, and then you're just left with 1, which is your sort of default 1 kilometre length there. So.
And this 1 kilometre is because?
That's what they decided it was going to be in the regs. No, basically it's because if you're working with, when you're working with your DNO, any further than sort of 1 kilometre away, they say it will be earthed or going through a local sub where it'll have a transformer. So chances are it will be earthed at that point. Again, when if we were looking at a stroke, by the time it had come any further than that underground, it would have dissipated quite significantly if it was on the cable installation.
Is that fact or an assumption, without me saying assumption too many times in this webinar?
I I don't know who did the math for this calculation, and this was obviously come from the standard. I personally wouldn't have used 1 kilometre. I'd have used 2, because that's the length that we know that lightning stroke will flow through. 1 kilometre was what they decided. So I'm just, I'm just working with their math.
Okay.
Lorna said, "Stand down. You're right." Interestingly enough, as well, I think we covered this in our podcast as well. If anybody is responsible for advising a building owner, and it's a commercial or industrial property, one of the biggest things as well with surge protection and lightning protection systems as an integral part of the building services is the amount of fire risk assessments. Somebody mentioned it in here in the chat about fire risk assessments. Most of them don't identify the lightning protection configuration as a potential source of ignition, which it is. So it's, again, quick sense check for people. If you are working in building management or advising building managers, maybe ask to see some fire, if you're doing anything on surge or lightning protection systems, maybe ask if you can see the fire risk assessments, see if there's any mention, because then that could possibly improve how coordinated they are. They'll probably won't be, they'll probably be a complete freaking shambles, but it's always nice to ask and show you're being diligent and thoughtful and all the rest of it.
I'm a little bit behind in the chat. I've just seen Cam and a couple of others say that there was no mention of surge on their 239152. Kirsty, have you ever been asked by a training company to write some content for their 2391 or to help them understand it, to deliver it to electricians in training?
So I don't know what 2391 is.
The inspection and
what would that
testing.
course be?
It's the inspection and testing one.
No, so I've never been asked to do that. I did NAPIT's training organisation, Premier Training, that NAPIT own. I designed their lightning protection course, so that is City and Guilds thingied.
Accredited program.
What's it, accredited? Yeah, I designed that, but no, I've never been asked by any other training organisations to do anything, although they really should start adding them sort of things.
Is it fair to
Especially,
say,
I mean, I know it's a separate conversation, but apprentices are coming through and know nothing about surge protection now.
Yeah.
And it's in our regs, it's something we use day to day.
this is one of the reasons why we tried to focus, obviously this year's been a complete blowout, but we tried to focus our energy on the colleges and the learning centres to try and help them, because there was evidently a need for the lecturers who were very hungry for information and content. I mean, well, I did my 18th edition and the lecturer skipped over pretty much surge protection, arc fault detection completely. I ended up covering that bit for him, which was very strange considering I was there to learn from him. One of the statements that I saw earlier on was, oh, well, we're waiting for the EICR or the NIC to inform us. And then they did their roadshows and just said, oh, you don't need this or you don't need that. And the reason they do it is because they're faced with 500-600 people going, oh, I don't need this, 20 odd years, la, la, la. And rather than saying, sit down, wind your goddamn neckins, shut the effing hell up. Yeah. We've got new modern equipment connected into really old crappy installations. We've got new detection systems which can now mutually interact. The rules of the game have changed. We're not doing enough of that when we're going and doing these seminars. Well, we did it at Alex last year, didn't we? We basically grabbed a mic and was virtually rapping to everybody in Ali Pali. But the industry needs to be a bit more sterner and stronger when we speak, not rude, but much more informed when we're speaking to Sparks. Say, this is our limits of our knowledge. This is what we understand. This may help you, but your journey of continuous learning, it's not going to stop now, especially with the way the technology is operating and smart homes and all the other good things that are out there. We're having to consider the selection far more.
Before we go on to the next bit, there was just one bit Daniel Casey's put in the chat about this calculation, which seems to be getting bogged down as calculations usually do. Just regarding page 103 about the distribution lengths that are unknown. Yeah, it does say that if the distribution lengths are unknown or partially unknown, then LPAL shall be taken as equal to the remaining distance to reach total length of 1 kilometre. Now, the example in there is that says, yes, that if she said it was underground 100 metres, then LPAL will be 900.
The remainder.
Now, the calculation we've got here, we've assumed that the underground cable is 1 kilometre, and therefore the remaining up to a kilometre is 0, and that's why we've got, in this particular example, LPAL being 0. But yeah, if you had, say, 200 metres of underground cable, then you would assume that the rest of it was 800 metres. So
LPAL is just not applicable because there is no overhead. Is that correct?
Yeah. So in this case, it's because we've got 1 metre, we've got a kilometre of underground cable, So there is no LPAL in this particular example. But there you are. This is
Kirsty,
just
you're
a
muted again.
calculation that you're probably never going to use, and it doesn't tell you a lot anyhow. And in reality, it's something you shouldn't be getting bogged down in and getting too concerned over. So I think we should move on.
John,
to
do you
the-
not
That's it,
do
I mean,
this formula much?
I call these installations, like I've highlighted on here, the unicorn installations, if anyone's done any training with me, because I don't actually think there is, if any in the UK, I would be quite surprised, installations that don't fall under the regulations where you have to install surge protection, or at least have a circuit that must have surge protection, or is not domestic. I mean, this risk assessment is only for all other cases, so there is no point in getting too bogged down about the whole thing.
It would just be easier if they just ripped it off, wouldn't they, and got rid of it?
It needs
Completely.
rewriting.
You know, there's
Completely.
so many brain cells are being wasted trying to understand a formula that really you're never going to use. And by the time you've concluded your formula, you've put more manpower into, and you could have put an SPD. You know.
Yeah.
Exactly. I think the issue is as well, you had your sort of your NAPITs, your NICs of the world, your ECAs. When this come out, they were like, do you know what? We're going to show everyone how to do this risk assessment. And they honed in on the maths, and they were like, we're going to look so clever showing everyone how to do it. And they completely missed the sentence at the top. As for all of the cases, do the risk assessment.
Everyone loves the formula.
You're right. People started this journey with, here's a massive risk assessment, and that's it. And it was actually no. The risk assessment is there in specific requirements.
So would it be best advice, maybe for everyone, to get a bit of paper, glue it over that regulation, and just put in an SPD?
For domestic, that would definitely be the answer.
That would probably be best.
If domestic.
Yeah,
SPD.
just put in an SPD.
I mean, just always make sure when you're looking at things that you read the full bit. Don't just read the line about the risk assessment, because I mean, page 101 where you've got your regs, your 4.4, there's the bit about the risk assessment. But if you read the entire paragraph and bit at the top about the risk assessment, it actually says except for single dwelling units. So the risk assessment is not relevant for single dwelling units. It's just people don't read the whole paragraph. They just pick the bit out they want.
Yeah.
As Sean has quite rightly pointed out, as I said before, it's only for atmospheric origin installation and damages, not surges and transients.
Yeah, and Richard Harrison's put in the comments that he was at Chesterfield or training centre there and asked whether the training centre itself had an SPD fitted, and he was told that they'd done the calculation and it wasn't needed. But as you said, because it's a college, it comes under one of the 4 indents anyway, which states it should be fitted. So again, the calculation was completely irrelevant, waste of time, no point doing it.
Yeah, they probably thought there's a sub on campus. Yeah, well, away we go. We'll be fine. So moving on, this is, if you are doing the risk assessments, is quite a nice little a map to have access to. It's in published document 62305-2. I think it needs updating because it's fair to say at the start of the year, I was down in the big toe of Britain doing some talks. And when this slide came up, one of the blokes shouted, well, that's handy. And I was just like, oh, right, yeah, okay, good point. I'm in the one part of the country talking about this. Well, it's pretty low. So this is definitely a map that's worth considering. I think it's in the regs, isn't it? It's a black and white version.
Yeah.
It is. And I'll just jump in. Although, yes, they will have been very happy that right down there, it looks very low on that map. In fact, although they don't get many lightning flashes, because they're coming off the sea, they actually have a lot of storms. So a lot of it will be happy to get lightning cloud to cloud rather than it physically hitting the ground. Most installations down there are actually fed by overheads. So if you've got storm activity, your overheads will pick that up. Although it's not a direct strike, it will pick up that. It's still of atmospheric origin.
So there's a difference between a strike and a stroke. Interesting.
So we need a storm density map.
We do. This was obviously a slide we put in that was trying to show it a little bit clearer, but I think we can probably...
Clear as mustard, mate.
Yeah.
I think we've done that to death a few times already. So.
I think we've done that. So just for everyone, there you go. La, 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 la. You can screenshot that if you want that. That's all good.
If you really want to do it, you can, but don't bother.
So we were trying to work backwards, but we've kind of already done it really, which was, when do we have to do the risk assessment? Protection against shall be provided where there is serious injury, loss of human life. It's very cleverly worded. Interruption of public services, damage to cultural heritage. You know, our colleges, public services, our railways. Is there potential damage to persons and human life? Is there interruption of commercial? That reg to me covers every goddamn thing.
I mean,
I'd love someone in the chat to tell me what it doesn't cover.
Yeah, the college example is obviously C, because interruption of commercial activity. So if the college gets blown up, they can't do any training.
I mean, commercial industrial activity is relative to nearly every client, isn't it? If it's a business that's going to make money, or a business that's going to manufacture.
Yeah.
Is there, I mean, other than cost and maybe reconfiguration of switchgear, is there a negative to SPDs other than that?
No, not from a technical standpoint in any way. I mean, if you were in the lucky case where you didn't actually have much surge activity, you didn't have transients on your installation, then it wouldn't cause any damage, and the device doesn't do anything other than protect you against that sort of thing. So it would only ever react when it needed to.
So your decision is only really reflecting on cost. That's the only negative to this, isn't there? There's nothing else.
There is. So there is an argument here. So for me, for instance, I'm, as we are well aware, as a little team, that I am currently about to be replacing lots of surge protection devices, and on some of them, it will involve reconfiguring the installation, because a lot of old existing commercial, and let's just broaden it out, commercial installation shops, there may not be space to fit.
That's just cost, though, isn't it? That's space for your switchgear.
It is, but at the end of the day, if you're an electrical contractor and you're going in there, and there are regulations that talk about the lengths of the conductors, and you're trying your best to achieve the lengths of the conductors, which I think is recommended 500 mil, maximum a meter. If you're trying to achieve that and you can't achieve that because you're retrofitting onto an existing installation, then you're kind of slightly buggered, because if you then go and do a best endeavours fit, and then you're inspected by your NIC engineer, and he comes along with his measuring tape and goes, no, that's not compliant. I think David Savory did a very good video where he actually installed a surge protection device, and people watching pulled him on the lengths of his conductors, and he did a very good corrigendum to his video.
Yeah, he was brutally honest with himself,
which was very great. Humbling. And to watch.
You have to ask the question. The information wasn't clear when you read the way it's written in the regulations. It's not very clear with connecting conductors, because it doesn't really speak Sparky. It doesn't speak Sparky.
No, it doesn't speak Sparky, and it's because I genuinely think the person that wrote this didn't really understand putting it in them. So I think that's why it doesn't read very well, unfortunately. You have a meter of cable for your installation when you're doing it, because as a surge protection device, we have to manufacture them to make sure we're not going to let too much voltage through on a circuit at its maximum capacity. So it's its UP, or its let through voltage. UP you'll see on the front of your product. So in our wiring regs, it gives us a maximum let through voltage of 2.5 kV. So we assume you're going to use up to a meter of cable. So we can calculate that meter of cable as 1 kV of volt drop. So we can use that in our calculations. So all our devices will have to be a minimum of a 1.5 kV let through, plus your meter of cable with 1 kV will give you your 2.5 kV maximum let through at a maximum strike. So that is why, so with cable longer, you're going to let through more voltage into your installation at a maximum strike, which potentially could cause more damage, essentially bypass the surge device.
And you covered that on your videos, didn't you, John, on your little series? Like, I think it was episode 5 or 6, where you showed the length of the cables and how the volt drop would occur.
Yeah, the length thing. I mean, obviously shorter is better, but again, there is obviously that 1 meter thing, which is in there. So if it's not usually that difficult to get it below that distance. I mean, obviously there are going to be circumstances where it's not, but certainly for the smaller type, certain domestic ones, then it's really not going to be an issue unless you've, for some reason, put your surge protection device in a separate box and then put a load of extended lead going halfway across the room to it or something. So, yeah,
I think the drawings themselves are confused electricians, because they have that. What's the name of that? There's that other earth bar, isn't there? What's that called?
Oh yeah, moving the earth bar closer.
Yeah, you move the earth bar. So a lot of electricians get confused there, but a lot of times that's actually just maybe the metal work of the switchgear as well. That's connected.
Yeah, so that's usually the easiest way to make your shorter. So usually where you're taking your live feed from your overcurrent, sorry, generally. So you're taking your feeds from there. Your live cables, you can't really get any shorter than close, if you know what I mean. But your earth, you can do something about. It doesn't have to go back to your MET. It just needs to be a local earth point, somewhere you can bond it to. As you quite rightly say, quite often that is literally the enclosure that it's into. As long as that is then bonded back to your MET, you are absolutely fine. So you can get it very close.
There's a question, you've seen that, Kirsty, in the comments, which it says, what if an SPD fails closed circuit and gives rise to risk of fire?
So surge protection devices are all designed to fail open circuit. So they don't fail closed circuit. And if they were, if you had installed them correctly to BS 7671, and I'm going to try to not feel a little bit smug about this, and you do have an overcurrent device up front, if your device starts to overheat at all, your overcurrent protection device will trip, therefore cutting supply to your overvoltage device, your surge device. Again, another really, really important reason to install an overcurrent protection device.
Okay. A couple of comments about training, which is good. I think it's something that we need to look into as well.
Yeah, Daniel Casey's put one, which is he went to a rental property where the lamps were constantly blowing, and recommended an SPD is possibly that, as there was a big hospital and lots of factories across the road, so switching transients from the heavy industry across the road may be a factor. I mean, if they're LED lamps, then yeah, they could be damaged by that sort of thing. And that's just another example of things that people might not think about in the installation as having some sort of value. Because if all your lights are breaking every week and having to buy new ones, well, there's a big cost that you don't need to be paying. So yeah, definitely. I have actually seen some LED lights which were damaged because there was two, well, there was a whole lot of them. There was two next to each other. One of them failed due to some internal fault, and the whole thing was all blackened on the board inside, which that was obviously an obvious failure. And the one next to it failed at the same time, but there was no visible damage on that one. So fairly likely that the fault that the first one caused, which would have caused a big sort of transient on the system, probably damaged the one that was directly next to it, even though that wasn't visibly damaged. It obviously stopped working at the same time as the first one blew up. So.
Can I just jump in for 1 second? Sean, you might be a very lovely gentleman, but obviously I do not know you very well. You really need to deign to comment last bit about overprotection. I just want to point out that 534.4.5.1 in the first line of it is SPD shall be protected against current with respect to short circuit currents. So we have to be very, very careful that yes, some devices are built that they can have a higher overcurrent protection rating than others. But we have to be very, very careful. In a specific circumstance, it would be very, very unlikely that you would be installing a Dane surge device on a domestic circuit in a domestic circumstance. We've got a rise of very, very low cost surge arresters appeared on the market now that you have to be very, very careful to what standard they are actually built to. Now, 7671 is giving you an overview and telling you there should be an overcurrent device upstream, purely for the fact that if something goes wrong with a surge protection device, that overcurrent there needs to be there, as I said, to stop that from happening. So relevant to what different manufacturers have said, if 767 says there needs to be overcurrent protection, then there needs to be overcurrent protection. If obviously that's not installed, you'd need to be able to explain why. I don't think seeing a YouTube video where he said you don't need overcurrent protection on their devices would be relevant.
And this is what really annoys me, if you mind me chipping in here, because I've got, and Sean knows this, I've got a brand new board ready to go, a fuse box board ready to go in, and I've got a main switch, and I thought I'm going to have my surge protection device next to my main switch because I was considering the short lengths and arresting the surge before it gets into my board, because I thought that would just be my best practice, my good practice. And of course, at the time I bought the damn thing, it doesn't have MCB protection. And I've spoken to the people at the device manufacturers, and they give you a wishy-washy, oh, yeah, it's fine. Well, you can use the DNO.
Is this the manufacturer that is now providing them with?
This is the same manufacturer that is now providing them with MCBs, and now I have a main switch where I feel like a complete twat because I've got the box, I've got it, and I'm like, oh, great, it'd be really nice to install it. Oh, no, I can't install it because I take the risk, because I'm not going to get anything in writing from them. I have asked them to release a number of data sheets and a number of various other bits and bobs, and it doesn't go very far, sadly. So that to me has burnt me with Fusebox a little bit, but other than that, the rest of the board and everything looks solid as anything. But yeah, that has annoyed me, to say the least.
I mean, my perspective...
They didn't tell you why they changed to suddenly not having one, and then, oh, now we suddenly do, because the actual devices they're selling look exactly the same.
They do.
They probably are. So
I should imagine they've just listened to other people and gone,
No, I actually got on the phone to their technical guy, and he said they had decided to change that to fall in line with the rest of industry. Make of that what you will.
Is that Kirsty's fault?
It's probably Kirsty's fault.
Kirsty's fault.
Kirsty, you troublemaker.
I may have wrote them letting them that they may be liable for action if they were not conforming to 7671.
Right. Yeah. No.
I mean, we had Dane on. Obviously, Dane talked about the fact they had internal protection, and then they went down the avenue of, in domestic you would need it due to other characteristics, but end of the day, manufacturers' requirements are manufacturers' requirements, and if you interpret some things differently, we can't make you fight to the death to see who actually wins. We have to follow manufacturers' guidance, and domestic field is your company and others. Dane, as you say, aren't really domestic market, and if you recommend this protection, then that's it.
No, I think when you go commercial industrial, the field does widen quite a bit, and there's some very, very specific and specialist bits of kit out there, to be honest with you. Interesting comment from, if I can find it, because there's about another 50 things just appeared on my screen, so it's gone again.
It happens. And by the way, Sean's a bit of a troublemaker, Kirsty. It's fine.
Yeah, just ignore Sean.
Yeah.
Mark Holmes, do the connecting cables need to be protected for short circuit, not just the SPD?
Where are you reading that from, dude?
I'm reading Mark Holmes.
Yeah.
Very, very good comment. Do the connecting cables also need to be protected for short circuit and not just the SPD? So I'm assuming from the circuit breaker into the device. I'm assuming they need to obviously be sized accordingly to carry the maximum value of whatever the breaker is and be protected from if there ever was a short. I'm assuming that.
So if they come out sort of the top of a main switch, obviously they wouldn't be protected. They wouldn't have any sort of overcurrent protection. But coming out of an MCB, you would.
That's a good point, actually. Richard Harrison, why do some domestic boards have the SPD at the end of the DB so far away from the main switch? I never got that, because I was thinking, if we're so precious about lengths, maybe I'm just being thick, but I always thought, why do you put the surge protection device all the way to the other side of the board if we're supposed to be measuring the length, and we're kind of, or are we not including the buzz bar that it connects?
That's it, exactly. So as Sean's just put on as well, the buzz bar is negligible impedance, so we count the buzz bar as basically being zero in length.
Thanks, Sean. Okay, fair enough. I'll shut up then. That's me being stupid again.
Also, the fact it's a flat bar is rather than a round conductor would have a effect on its inductance, wouldn't it? Perhaps we shouldn't go into that too much at the moment. Yeah, it's not.
That's
a whole other rabbit hole, John.
Thank you, John.
I was going to say, John, that's podcasts. I think that's episode 18 of the surge protection debate.
Richard says, but it will be further away from the origin.
Well, it is, but the distance from the origin isn't the relevant distance from the surge protection device. You could have your origin in the next building.
It's the connecting conductors, isn't it?
Yeah, it's from the SPD to the actual installation. It's not where the origin or the meter is or anything like that. Because say you could have that 50 meters away in a cupboard. That's irrelevant. It's where your connecting it to the rest of the stuff that is the point. So
Sean says, "Can you guys explain the 820 thing without a chart?"
You want me to give it a go?
Yes, please.
Go for it.
So you hear the 820 and 350. The 10350 is the waveform for a type 1 lightning protection device, and an 820 is the waveform for a surge. So now, if you imagine this then in like a little hump, so the 8 is the front of the waveform, so it takes 8 microseconds to get to the full extent of the surge. It happens very, very fast. And it's 20 microseconds for it to dissipate to half
Its life, half its energy.
Yeah.
And this is
Exactly.
microseconds.
So they call it an 820 wave.
Yeah.
Microseconds.
Yeah, microseconds.
Very fast. So that's a little bit of energy. So when you're looking, so you've got a little hump, and then when you're looking at a lightning, you've got a 10350. So it's a 10 microsecond wavefront. So it goes up to 350 very, very quick. And it takes 350 microseconds to get to half of its half-life. So you imagine it's a much bigger waveform. I can't see my hands. Much bigger waveform than the
This is sometimes why I've said that sometimes we need to think of SPDs as a little bit of filtration, because you've got a peak, but then the let through may still be too much. And then you may need to have another one, because obviously, the type 1 takes that large peak, but if it lets through energy that is still too much, we'd have to put another one in there. And that's what we may have combined.
This is why you have combined devices. So I always describe them like a funnel when I'm doing my training. So if you imagine a type 1 will take a massive lightning strike, but lets through an awful lot of energy. So then you have your type 2 to catch that, to make that smaller. And then you have your type 3 elements take that and make it suitable for end equipment. So it sort of filters them through. So usually when you install a type 1 device, it will actually be a type 1 and 3 combined unit. So for that panel, you have all the surge protection you need without installing additional devices. It's only then when you go further into the installation where you look at more devices.
Yeah, and that's also why people, like particularly customers, say, "Oh, I don't need the surge protection in there because I've got this horrible plug-in extension lead with it inside."
Yeah,
that's why, because obviously the thing in the extension lead is not going to stop the whole of that energy at the front there, and all that's going to happen is it's just going to explode in all the flames, and the equipment's going to be damaged anyway. So. And the same applies for, "Oh, my TV's already got one inside on the circuit board." Well, good for that, but that's only for the little tiny bit at the end once other devices have done the business. So you can't just buy a £5 extension lead and plug it in and all is well. So not going to happen.
Yeah, I mean, these are microseconds. Okay, don't think of milliseconds. These are microsecond duration of time. Nothing else operates as quickly. So I remember having to learn all that back in Amendment 1 when it started coming in.
Right. Shall we move on to the really controversial
If you
stuff?
try and imagine how fast an RCD reacts, a surge device reacts an awful lot faster than an RCD.
Yeah.
And an RCD is there to stop you getting electric shock at the end of the day. It's a very integral piece of kit. So if you imagine that's your surge device, makes that look slow.
Very slow.
Yeah, because we look at RCDs with milliseconds, isn't it? Is it nanoseconds, or is that the right term?
Microseconds, nanoseconds.
Yeah,
microseconds,
microseconds and nanoseconds.
And I mean, RCDs, the rule of thumb I always had for an RCD was a blink of an eye. 30 milliseconds, a blink of an eye, but you can't compare the surge protection device, so you can't sit there. Now, interesting, before we do move on, there is a rumor, a swell in the industry that you can use test kit to test these devices, that you could effectively use an insulation resistance tester and go, "Woo!"
You make Kirsty facepalm, dude.
Facepalm, Kirsty.
Yeah.
But can we just be clear here that as far as I'm aware, there is no device that, especially a standard, MFT or kidney bean type tester, that can generate a rise in voltage that quick to actually test these devices.
No, that's it. I mean, the thing is, in theory, every tester, no matter how old it is, can do this.
Mm-hmm.
If you can put 500 volts through a surge arrestor, which we all do when you do your IR testing, you can make your surge device activate.
That must mean it works then, surely.
And you'll be able to see, so you'll be able to put an earth, if you connected up the earth clamp, you could put an earth clamp around the earth on the surge device and you could see it work.
Yeah.
If you tested at 250, then the surge device wouldn't work. So technically you can do it.
Mm-hmm.
One, I wouldn't recommend it because you are degrading your surge device as you're doing it.
Yep.
Another than morbid curiosity, I'm not really sure why you'd want to do it.
Yeah, I agree.
But yeah, these surge devices are all built. I mean, they're built to 61643-11, so that's their testing thing. They all have to have status indication.
Mm-hmm.
So a surge device has to tell you if it's working or not. So you don't really have to be able to test it.
And that's one of the key. I think one of the things that's kind of stifled the debate as to whether people adopt it, because as electricians, everybody likes to see something work. You know, we inspect and test the installation, we measure earth loop impedances and fault currents, and we ensure that there's functional switching in devices, and we can prove the RCD works, which is great. And now here's this new device, and there's no show and tell. Now, yes, the guys in the chat are absolutely right. David Savory and a number of other people they have shown it on their videos that you can actually get a reading from your device.
That's
But
just
again,
forcing the device to do something.
Forcing the device to do
That's not
something.
verifying the device actually operates as required.
As required.
Frequency is no representative.
Exactly.
Yeah, I mean, I did that in a video just to demonstrate that 250 isn't there effectively, and then if it's 500 above, it is there, and therefore it conducts. But I say that's not actually testing that the device is doing its thing. That's just a demonstration as to how the basic principle of these things is. So
it's like verifying an overcurrent device will trip by shorting something out. It doesn't verify it's going to work at the requirement it's designed to meet.
Yes. Yeah, you're effectively forcing something to occur, aren't you? And you're not going to the fact of the matter is you're never going to attain the voltage that could appear, because it's an unknown quantity, isn't it? At the end of the day, if you have a stroke or a surge, that voltage could be of any number of ranges of thousands of volts. You don't know. This is, to me, a fit passive device that will tell you if it's working or not. If you start measuring it, I think then, yeah, fair enough, we're inquisitive, and I'm sure every spark under the sun will measure it, and maybe have one in their glove box that they can show the apprentice, fine. But the principle is it's a fit, and it does its job as and when it needs to, and it will tell you when it's failed.
You said you're right. I mean, sparks are inquisitive, and if we see a device, we want to make it function. We want to make it do something. And with SPDs, all we can do is force it with 500 volts, but
yeah, I mean, if
doesn't verify it.
Get a cheap one from somewhere, like some imported thing, and just play about with it and see how it works. But
sounds like Paul's got a couple spare.
Yeah, if you're going to fit them, don't do that on ones you're installing. Because there's no point, and also obviously it could cause some damage. So
yeah,
that's why they have the.
That's it. I mean, somebody's just asked there, when would you need to change a surge arrestor? And the simple answer is when it tells you it needs changing. As I said, these devices all have indication. You don't need to change them if the indication isn't indicating that you need to change them, basically.
So as an electrical inspector, if I see an SPD, what decisions can I make, or what decisions should I make? Is it just about suitable selection? Is it about the right type, connection method, or do I just say, oh, status is okay, move on? In your view,
in my view, I would be looking at it. You know your eggs on. Oh, I heard Alexa or something like that.
Yeah, Alexa started talking on my phone. I apologise.
No problem. I was just checking it wasn't anything to do with me. I would be, you know your regs on surge protection, you know you can't have too long cables. I would be making sure the cables weren't reasonably long. I would be checking the device indication to say that actually it's on and it's working and it's got power going to it. And then I'd have a look, I'd have a think about it. I mean, if you do some basic training on surge protection, I mean, I offer free webinars all the time for anyone that wants to jump on. There's only 2 instances where you'd need a type 1, and that's if you've got an overhead line feed in a building or you've got an external lightning protection system. So they're both where you've got a direct strike that can come into an installation. So if you know that and you know the building's got an LPS system, you go in and say, do you know what, that's a type 2, then you can code it as that. You know that that's not correct. But if you don't know and you don't really want to learn any more about surge protection, the basic thing you can do is go in and make sure it's working. I think that's all that's required on the test sheet at the moment. It's literally
I think it's just verifying its status, I think.
In terms of an EICR,
Exactly.
I mean, you're going to do the same things you would do for any other circuit or device. You're going to be looking at the size of the conductors, that they're connected correctly and they're not sort of missing, loose, hanging out, burnt, chopped in half, and insulation missing, and all the things you would normally do anyway. for anything else that's part of the installation. So most of it is what people are doing anyhow. So
I think excuse me, Daniel Casey made a comment. He said blank company demonstrated their unit at testing the SPD at LX, called Varista testing function, if I remember rightly. Yes, there are companies that actually market their devices as testing surge protection, but it's just as dumb as saying this is a Part P compliant piece of test kit. You're missing the point. You don't want to be blasting this thing with your voltages. You want it to sit there and do what it's designed for, the atmospheric or stroke voltages that could occur, and that can do its job properly, rather than you blasting it 50,000 times.
You need to remember, it's those testers are only limited by the mains, or they're limited by the battery power. They cannot represent the frequency, just the rate of change, the magnitude of that. You can't achieve that, especially in something that's on your bench like that.
Daniel remembers JW's video on the SPDs. What a bag of crap that was. It was utter rubbish.
Yeah, it was, and that one was imported directly from China, and it was basically the cheapest one I could find, knowing full well we'd have to destroy it, take it apart, and whatever. So that's why it was such poor quality, because it was getting exactly what we paid for, basically. It cost about, I think it was £4 for 2 of them, or something ridiculous like that. So, yeah.
Mark,
sorry.
Sorry, Mark has asked, can the SPD have a buzzer built in to indicate failure, not just the flag or light? It's a very valid question.
We do a Type 3 device, so one that's designed to go the end of a circuit behind like a socket, or if you can't see it, they will have audible alarms in them, like buzzers. Ones that go in panels don't have that, but they all have a remote contact, so there's no issue you wiring an alarm to it. You can always wire an alarm to it, or wire it to a building management system.
Any kind of management
more complex
system.
thing. Exactly.
Yeah.
But yeah, just even a basic alarm contact would be absolutely fine. So it would let you know the device needs changing. We have devices now all the way through our range, from domestic through to your massive industrial devices, all have remote contacts. It's not too much of a bother to
That could be as simple as a battery and a little buzzer wired to the 2 contacts, and when they close, it makes a noise. So yeah, very simple, or obviously to the more complex end. So
I have actually suggested to a couple of manufacturers that it would be really good if there could be like a little LED light on the outer casing of the boards, or somewhere on the board, that just lights up or flashes or blinks if the surge protection device is on its way out or is blown, just to try and attract the homeowner. This is for the domestic boards, the homeowner's attention. Ooh, what's that mean? And there's maybe a little sticker or label around it that says SPD replace. That I think would be quite cool. Just an idea. I'm sure loads of blokes on this that idea as well.
Before you go on to this EV question, I want to just ask a question to Kirsty. I'm right in the middle of assisting Father Watts. He's probably gone to bed now. 7909 is events, temporary events industry, and we were talking about surge protection in the event industry and just the lack of consideration. Have you heard anything, or have you had any involvement in SPDs being adopted into events and things like that, or in distro?
I've given them my 2 pennies worth, but that's about it. I mean, if you consider temporary events, so because it's temporary, they don't consider having to have surge protection as standard. But if you consider that you could have a field full of people at a festival, a temporary event, where all the TVs are actually that are designed around the installation are actually used for emergency evacuation procedures, so they'll direct you to the nearest point, things like that. Now, if they have a nearby lightning strike, or even a direct strike, which could happen if they're in the middle of a field, that would take out their entire fire management system. And it could cause carnage. I mean, aside from the fact most of these people are going to be drunk and whatever else, they'd have no emergency evacuation procedures, because it would actually they're all electrical. So for me, I think it should definitely be considered in event systems and temporary events, definitely.
Does this not raise an issue that I think Daniel and a few other people are finding on their journey of standards? When you start looking at standards, there is a disassociation, an overlap, an overlay, an underlay, whatever you want to call it, where you can look at the latest requirements of 7671, then look at 7009 and go, well, there's a gap. or you can look at I mean, I was reading a standard today that referred to, I think it was Amendment 1 of the 17th edition, which is kind of one of the dangers when you reference another standard. I personally don't believe in referencing what the addition and revision is. You just say, refer to that standard, latest edition. At least it buys you some time for that person to apply their engineering judgment, rather than, oh, I've got to look at that past standard, which sometimes does happen. But yeah, shall we look at the controversial stuff now? Because
Go for it.
I think it's fair to say, and let's just throw some knowledge out there. I probably should have put it in a slide, and apologies for not. There has been a recent investigation from the Department for Transport into EV installs, and there was a public report that was issued on their website. I'm sure we can probably provide it. And there was also a letter from the Department for Transport, which was from the government minister, telling EV, I think there was I can't remember at the top of my head, but there was a percentage of installs that were done non-compliant. And so the government minister was writing to the OLEV registered installer saying, please get your act together. The same could be said with EV in general, including maybe the standards and requirements around it. So my question to you, Kirsty, is electric vehicles, given all the issues we're focusing on OPEN, this was asked of me a while ago, and I had to think about it. Do you believe that EV vehicles need surge protection?
Yes, without a doubt. So even before we consider the OPEN, right, so before we start looking at that technology,
Yeah, sod that.
you are just basically allowing voltage into your installation. So when you've got your AC/DC transition to be able to have your car charger, that will leak voltage onto your electrical system. So you're going to be essentially importing voltage into your installation. So no matter what installation that is. And then if we go down the route of the OPEN stuff, where you have very, very sensitive electronic equipment, trying to make sure that that's there to notify and disconnect if you lose your neutral. But that technology itself is very, very sensitive. So that technology needs protecting against surges.
All that technology needs protection.
Exactly.
Yeah.
So it's just exacerbating the gap between our electrical systems and the technology we're using. It's just another example of why surge protection is becoming so relevant in today's society.
So just a quick one on this then. I think it's fair to say a couple of months ago we went down the rabbit hole of looking at the complexities of electric vehicles and the offerings and the standards, and our Instagram page has got pictures of all the different committees that deal with cars and the various components and parts of it. And we did find in one of the more recent EV charging standards, it was very clear. I think I put it on Instagram where it did actually state, I'm not going to look at my phone and do it at the same time, but it did actually, there was a statement in one of the BSEN standards for EV charging that surge protection devices should be provided, but it doesn't seem to have worked its way into our regs yet.
The way it's considered in the regs is that the relevant parts of 443 should apply. So anywhere where you have OPEN technology, realistically, that comes under life safety certs if you apply 443 correctly to it. So if you're using OPEN technology, you should have a surge device, but it does not actually state that it doesn't say it in the EV section. So you've got to again apply your knowledge of the regs, and you've got to know them regs to be able to do that.
There's nothing in 722 that refers to 44.
No, there's not.
Or 534.
And that is what I requested for this to occur. I'm hoping it's something in the future that will happen.
In fairness,
as we've already discussed it.
560.6 electrical sources for safety services, generator sets independent of the normal primary cells, storage batteries. There is definitely specialist requirements for safety services having sources capable of operation in parallel. There's plenty of stuff that references and kind of drifts around it, but nothing on surge. It's the choose your own adventure, isn't it? It's you stitch those parts of the regulations together. Nah, because what you'll end up is exactly what the DFT have written to thousands of EV installers, saying please go back and fix your installations. Guys,
that's it. I mean, if you speak to an EV charging manufacturer, these EV charge point manufacturers, and even at some point the car manufacturers, they will tell you that their technology should be protected against surge protection. but it will be on some very small writing somewhere, the same as you get it now on some LED lighting manufacturers putting their warranties that the warranty's void if there's no surge protection upstream. It's all there, it's just people don't talk about it.
Does the vehicle connecting set not have SPD integrated protection by default?
No, it doesn't.
Okay.
Yeah, Richard Harrison in the comments has put, can the car electrics be damaged by surges from the house? And the answer is yes, they can. And for those that don't know, your home or your typical home charger, all it's doing is providing 230 volts AC to your car. So if you get something that's damaging stuff in your house and your car has to be plugged in as well, then yeah, it's going to damage the equipment in your car. Because when you're charging on AC, the actual charging unit that actually charges the batteries with DC is in the car itself.
In the car. It's in the car by then.
Yeah. The thing on the wall is literally just basically a contactor and a couple of other bits to switch it on and off that just turns on 230 volts to the car. And then the car is what's doing the actual charging the batteries and determining what rate of charge and whether the batteries are full, empty, and all the other stuff. So in that regard, the car is just like any other appliance in your house. And I don't know what Tesla charged to repair their vehicles, but if it, say the charge on your Tesla was blown up, I can't imagine it's going to be £100 to fix it somehow. So yeah, you certainly should be considering that. And the only difference then is if you get into like the fast chargers, those are DC, and that is where the charging unit, which is usually one of those massive big pedestal things, that is actually putting DC direct into the car. So that's slightly different. But certainly in your house, you're not going to have one of those. So yeah, your car is like your television. It plugs in and gets 230 volts into it. So,
just on top of that as well, there is a this is more for probably for the Daniels this world. There is a standard you don't have, Daniel, BSEN IEC 61851-1 2019, which is part 1. There's many parts of it. An electric vehicle conductive charging system. When we were doing our research and melting our brains, we realised there were lots and lots of BSEN standards regarding wireless transfer and EV charging leads and all sorts of stuff. But yeah, when we actually started getting down to it, we realized that there was a common theme. And I think at the time, I think I actually probably screenshotted it and sent it to you guys as well. I just need to dig out the clause, but I haven't got time here. So maybe we'll put these into the Discord later on or tomorrow or something where we find all these.
We've also got to consider, obviously we've got our 4 points where we have to put it in, and one of them is public service, loss of a public service. So if it is a public EV charge point, it also falls under that as well.
Yeah.
Yeah, you really can't get away from those 4 points, which cover 99.9% of everything, and what's left over is pretty much nothing. So yeah, it's inevitable that surge protection is going to be required. In
so let me get back to the point of this coding then. Okay, so I think we're all agreed that there is an interpretation of 7671. So Dave, can you run a poll, please? And just for shits and giggles. It'd be really interesting if people went into a domestic house now and they saw an EV charger point, because we know people are using socket outlets and all sorts wrongly and various other, extension leads. But it'd be really interesting if somebody did have an EV charger and there wasn't surge protection at all. Would you code it? And what would that code be?
Right, so no surge protection at all.
Yeah.
Okay.
Let's be controversial, or let's just speak the truth.
As a side issue, if your electric car was damaged by a surge, would your car insurance cover the repairs?
Oh, John.
I don't know, because that would be seen as electrical damage, not as a...
Yeah.
Very good question. So let's see what people are going to say.
I'd love to know what goes on in your brain, John.
I would love to know what goes on in John's brain. John would like to know what goes on in John's brain.
That's what it does. You'll hear it now. It goes, That's what.
in all fairness,
that's all you get back from John many times.
Yeah. I've always imagined it to be something like Willy Wonka's chocolate factory, a place of amazing things.
Or the music.
Oh yeah, every time comes into my head.
Yes, old Father Watts is still in the chat and has put so 10 to 20k's worth of electrical equipment in the car that could be completely destroyed. No brainer, surely must install a surge device. Well, there you go. As per,
well, it took Kirsty less than half a second to go yes when we asked her if electric vehicles needed this protection. She didn't dawdle. She didn't think about it. So
it's exactly the same. How many solar systems do we have installed on installations, PV systems? And again, you've got exactly the same thing, except the difference is you've strapped a piece of metal to your roof. Yes, if you are doing any sort of inversion, there should be a surge device involved.
Okay, 76% have voted, so that's pretty good. There we go. 64% have gone C3.
Oh, we're nervous. We're all nervous. This is a new way of thinking, new way of coding.
28% went C2.
And 3% went sod it C1. Well, that's just Sean, isn't it? Going C1 happy, or your dad.
That's probably Father Watts. C's the C1,
Father Watts. It's interesting because this is the whole point of these webinars, is to expand our way of thinking.
Yeah, and we never say it's this and you're
team.
wrong. Everybody's right because everyone's applying their engineering judgment here.
Yep. And that's the whole point of putting these on YouTube, so that you can watch back and see where we make errors and mistakes, but we're all human. I can see this being a thing, Kirsty, in the next 5 to 10 years. I think eventually, with hopefully the wiring regulations committees leveling themselves up a bit and providing better clarity, I can see this being if you want that expensive technology where there is risks, you need to have the appropriate, again, I always say this, the appropriate selection erection. And for anyone who wants to know, PD IEC TR 62305 uses a wonderful term that I keep using: availability of the protective measure. When you're selecting and erecting, what is the protective measure? If we don't know what those protective measures are, we're kind of we're just falling at the first hurdle, aren't we?
Yeah.
That's
why 7671 is in that order.
Yeah, Steve's got a good one in the comments, says, what happens if the householder says they do not want surge protection, even after you explain to them what surge protection devices are for? Well,
go and explain it and put it in.
The thing is that if it's required, then it's required. It's not something you can not have because you just don't like it. And it's the same as if the customer said, oh, I don't want RCDs on any of my circuits. I mean, too bad, they're needed, so get over it. So,
I guess this is the point. Is SPD really a consideration we can offer the client, or should we actually have it implemented in design with our observations as electricians?
I think it needs to be selected and erected accordingly.
Part of the design, like the rest of the installation. So you can't have customers saying, oh, I don't want insulation on my wires, I'd like to have bare copper wires strung across the ceiling. I mean, it's not going to happen, is it? So if it's needed, it's needed.
So from my point of view, what NAPIT and NIC of what I've heard them telling people, as you know, they tell people an awful lot of things, is essentially that because we've got that get out in the book that SPD installation, we can omit it. If the client doesn't want it, they don't have to have it fitted. The electrician then get it signed to say they have recommended it, they've done their due diligence type thing. But I'd say if there's open technology being used, then that would push it into, actually, you have to have that fitted, even if it is only for the EV charge point.
I think as soon as you're getting customers or clients to start signing things to say they didn't want something and they're going to accept liability for this and that, that is a very dangerous route to be going down.
Definitely.
And something you should definitely avoid, because in the end, who's going to prove who signed what and when, and it's just a big pile of mess you're creating for in the future. And certainly for domestic, bearing in mind the cost of the thing you're talking about is very small in the scheme of installing whatever they're having installed. So yeah, it's not something that's optional. It's either needed or it's not needed, and if it is needed, it goes in. And if the customer doesn't want to pay for it, well, they don't get they can go to someone else who is going to do a crap job and other stuff as well. So
okay,
perfect.
On this one, 63% C3, C2, which is great for, I think this is the first time we've discussed this in a public forum anyway, which is good, because this debate will continue to merge and develop. Other people will join the debate. Some people will frown, some people will sneer, some people will laugh. Some people are some people at times. What can you do? But yeah, 63%, I think there is an issue here, and it's fairly evident EV is still, this is one of the reasons, John, I haven't gone and done my EV charging course yet, is because I'm waiting for, I'll be honest with you, I'm waiting for a few amendments of the
the book's going to have a fifth version.
Hey?
Do you think the book's going to have a fifth version, the Code of Practice?
Probably. Definitely, I think.
Yeah.
The course at the
20
moment
quid on it.
is already out of date because the actual questions, the CNG...
You did the course 3 weeks ago.
Yeah, this was like 2 weeks ago, and the questions are based on the 3rd edition and not the 4th edition, because they haven't updated it yet. So, yeah.
I blame
I'll be impressed if they stop at 5.
Yeah, I blame the training industry, Dave. But so anyway, right.
So do
we
I.
said that we're putting
Hands
some
up.
coding in. So let's go for the next really controversial thing,
For it.
because this is about expanding our thought processes and inspectors. So there is the potential, and I think we're all in agreement, there is the option to code, because we code against requirements and regulations. So let's go. Oh, there we go. In fact, there's a little I think we put this on our Instagram page, but according to HSE statistics, each year there are around 400 reported incidents of broken pens, protective earth and neutral combines. I think you can see the pictures. We've done that to death on TNCS, also known as PME, with around 10% of these causing electric shock. When the pen conductor is broken, the neutral voltage can rise with respect to true earth, and the protective earth forms part of the return path for any current that can flow, hence the last part of last week's webinar. And also our commercial one where we showed you some pictures. For an EV car charger, this means that the body of the car forms the return path, presenting a real risk that anyone touching the car will get an electric shock. And this is why the 18th edition of the wiring regulations tightened up under, deep breath, 722414141. I don't do the dots anymore, it's a lot easier. On the installation of EV charging points for domestic installation. Kirsty, what's your view on this? Oh, there we go.
My view, if you're using that technology, open technology, then you should be using a surge device. That technology itself needs protecting. I don't think there's any way of getting away from the fact it is a risk to life if you lose that technology.
I think it's fair to say that I think with EV, and this is just my personal opinion, there is more debate, more knowledge, more understanding, because whereas the principles of running a supply out to anything have never changed, the implementation and use of different technologies is making it a little bit more, how do we understand the full system? It's like with arc fault, John, we were talking about this the other day. Some arc fault detection does line and neutral, some may not. So the principle of arc fault detection is, well, do I actually know what I'm getting protected, or do I just have a rule of thumb in my head?
Well,
So
we saw that with the devices themselves, didn't we? When they were
we
first being moved into single module, we saw a few questionable ones that were claiming, and then we even asked the manufacturers, "Are there any compromises?" And some went no, some went yes. You know,
yeah, it's smaller, so we've had to compromise, and one of them is a single module which doesn't look for series arcs on the neutral, where with quite a lot of fires and thermal issues on neutrals. And what I think, John, you found one the other day for 88 quid.
Yeah, which I thought was surprisingly cheap compared, because all the others are sort of 120, 150 and above. So
yeah, 200 notes.
Yeah, so
I can't remember what the standard is off the top of my head, with fault protection standard. I believe they do have to protect live and neutral.
62606, I think it is.
That is, I'm sure, to be used in the UK, I'm sure they have to have live and neutral protection, same as a surge device.
Yeah,
we thought we looked at one, and it definitely didn't have protection on the neutral in the series protection
one, isn't it, John? If I remember rightly.
Yeah,
I believe you'll see a few of them being recalled.
So yeah, it's one of those areas that's sort of all up in the air, and what you get is, who knows? Let's say different people, you get different stuff. So
yeah, I think people naturally are cynical, and they're taking I think more people want more guidance from the industry bodies. And I think one of the things is, if the industry bodies won't give you that guidance, or have that difficult debate or that challenging debate, or understand your feelings and views and how you learn and process stuff like these webinars, I think are a great way of us all sharing and debating our knowledge. This is another slide that we thought we'd throw in, because we're kind of reinforcing surge protection here, not in a sales pitch way, but just we've used this slide before, Dave. It's the rise of prosumer, the person who consumes, obviously is the old way of looking at it, hence the 1970s handlebar tash. And then the modern world of someone who consumes and produces becomes the prosumer. Bidirectional current flow there, surge protection considerations accordingly.
Yeah, and obviously we've looked at, we've already discussed the importance of consideration of surge with PV and EV as well. So this is interesting, because we've got some homes now that are, I think it's fair to say, there's probably a percentage of homes in the UK that are they're presuming. Let's be honest about how many council estates are presuming now they're producing energy.
how many of them do you think? So let's pretend I'm going to do some EICRs, because let's be perfectly frank, social landlords legislation now, 30, 40, 50 quid at EICRs. How many inspectors do you think are looking at the solar panels on the roof and saying, is there surge protection there?
Many.
It's a generator.
Stuart's got to go. See you, Stuart. He says
Sorry,
he's
Stuart,
learned.
take
He
care.
says he's learned a hell of a
We're
lot.
nearly done anyway.
Yeah.
What we've got to be careful about with solar panels as well is not just, so if we go outside the remit of most domestics, if you're working on anything that's got a lightning protection system, they either have to be cross-bonded to the lightning protection system, at which point you'll need to have a type 1 on your solar panels themselves. If not, they have to have a specific separation distance to make sure the lightning would not jump from the LPS system onto the solar panels. So you've got to be very, very careful with solar panels and sort of the installation that they're on.
So I'm actually installing a lot of solar, and we're actually putting DC surge protection before the inverters, which I actually had to insist upon, which was quite hysterical. And then I went away and dug out a load of BSEN standards, and lo and behold, in there it actually said you will put surge protection on the DC side as well. And I think one of the biggest challenges I've found with solar on a commercial aspect is the inverter manufacturers are all Chinese, and they talk absolute gobbledygook to try and get away from any questions.
But to be fair, I mean, PV training itself was thrown out in a boom market.
Yeah.
Things like microinverters and stuff were barely even technology at the time. And a lot of things was, this up to the inverter, then DC isolator done. There's not a lot of discussion about protection of the DC side of the array at the time.
I think that there's more attention needs to be paid to this, and I think in time, maybe this is another webinar that Kirsty, you might want to do, where you cover domestic homes with, PV systems on it. But I think this is going to be if I walked in and I was doing an EICR on someone's house, I would see through it straight away, to be honest with you, and I would say, where's the surge protection on the PV system? Again, it needs, depending on size, etc. I would look for it. I would look as an inspector. Is there a sufficient warrant or need for surge protection on the generating side of the PV? Something needs to be considered. I know I'm doing it at the moment, and I know the BSEN standards require it. I think it's only a matter of time before the regs catch up, but it's something to consider. We're going to move on from this one because I haven't put a coding one on this one. Well, we're going to
a couple of guys have mentioned about the Q&A. Yes, we've seen them, guys. We'll get to them.
I haven't. Sorry.
Yes, there's a couple of questions and answers.
So many monitors. Oh, okay.
Yeah,
this one here. Sorry. Fire alarms.
Fire alarm.
You walk into a building. There you go. There's a fire alarm panel on the wall. Code. There's no surge protection. Is it codable? And if you saw that, please forgive the flames for dramatic effect.
Yeah, the flames aren't actually there, are they?
They're not actually there. That is pure CG. That's magic.
Well done, man. All right.
Thank you. It took
we should relaunch the poll on this?
Let's launch the poll.
All right.
I know everyone's thinking the flames are never going to get to the fire panel. That was just emphasis. Having a fire inside, definitely a C1. Don't code the flames.
For effect.
Yeah.
That's a very good fire panel actually you've used, because it emphasises how sensitive this equipment is now getting.
Mm-hmm.
Yeah, I mean, fire panels of old was literally just a box with some LEDs on the front that went red when the thing occurred. But the new ones, it's a computer in a box basically that monitors all the zones, and it tells you exactly where the faults are and the fire is, and it's
all addressable. Yeah.
And of course, they're not like 50 quid either. They're expensive bits of equipment, and if they get damaged, then it's going to be a big pile of money to replace.
They're fairly critical as well. Here we go. 57% C2, 38% C3.
So we're obviously well done to both for C2, C3s. Limb, 2 people on the limb. I can see why they've put limb, because how far is your extent and limitation? Let's pretend you're working for me, which is pretty much everything, with the exception of cables buried in walls, because yes, I am a bit of a taskmaster in that respect. But for me, I actually agree with the C2s. And the reason being is I can quote regulation here 56010, fire detection and alarm systems, which we're going to cover in another webinar, because everyone says you can't code fire alarms. Why the hell not?
It's not within our scope, or is it?
Or is it? Yes.
That's the question, isn't it? It's the same with emergency lighting, the 5266. It's not within our scope, or is it?
Or is it?
And yeah, lazy sparks, unfortunately, from lazy training, I have to add.
Yeah, and I think it's more the lazy training.
Yes.
We are the product of how we're taught.
Yes.
If we're taught poorly, don't get me wrong, I picked up bad habits from the people who taught me, but I was very lucky. I worked quite a number of jobs when I was younger, keen to learn, and I took the best of the best people and learned from the worst of them to try and not repeat that. But I'm still learning every day.
We are going to do another one of these where we look at emergency lighting and fire and decide what we need to understand beyond the realm of 7671 to comply with 7671.
We have to. Just to quote BS 5839, which would be this fire alarm panel, part 1 is referenced 7 times in 7671 alone. So don't think this stuff isn't. There is a reg in 5839, as we know from our podcasts, that says you will comply with 7671, and there are more than one regs in 7671 that says you will, when doing fire alarm systems, comply.
Again,
So
a lot of people,
etc.
a lot of people went on the 18th edition course, for example. If they go to a standard that's mentioned in the training world, that means, oh, it doesn't matter because it's not in our exam. Let's not look at exploring that because it's not in your book. And they're not going to then invest in that unless they're the strangers that we have in here, like the Daniels and the Daves that spend all their money on these standards. A lot of sparks won't go into these other standards, and so they'll stay outside of their scope and outside of their working world.
I would be looking to put a Type 3 device near to that power supply. If I was looking.
So from my point of view, I would be ignoring the fact that fire alarms are maybe or maybe not outside the scope of 7671. What I'd be straight away looking at, a fire alarm system is a life safety critical piece of kit. So it falls under risk if your fire alarm goes down. So in the event you had any sort of fire within a building, that could create electrical damage, which could create a surge in the system, which could send down your fire alarm. If you do not have a surge protection device there, you might have a building on fire with no fire alarm. It's a life safety critical piece of kit. It would be a C2 for me.
Is it fair to say that unless obviously the fire alarm is in like the same area as the switchgear, in most cases you're going to want a Type 3 SPD adjacent to or in very close proximity to this panel?
Exactly. So you want your specific protection for a fire alarm, so it would be a Type 3. So as Paul quite rightly said, if you want to protect something specifically, it's a Type 3 at the end of the line. So that was what you'd put. Usually I generally say in the fuse spur feed in that fire alarm, put a Type 3 device. That'll then protect that specifically.
Cool.
Yeah, from the comments there, Sean's put, do fire panels not have Type 3 on board? Well, they might do, but the key thing is that if you're going to put a Type 3 there, that's not just it. You still need to fit the surge protection in the main distribution, because the Type 3 only deals with that little bit at the end of the waveform. So just bunging a Type 3 in and saying all is well, that's not good enough, because that's the same as getting that cheapo extension lead and plugging it into your TV. That on its own is not good enough. So you do need to put the rest of the stuff in, either the 1 or the 2, where the main panel or the main electrical intake is.
It's also
cascade. So that's cascading protection that John's alluding to. So where you sort of work your way down the system.
I was also going to suggest that it's probably worthwhile when you are doing the EICR, if it's a new fire alarm panel with modern electronics and possibly batteries, where if you open up that panel and there's a little battery backup to keep that running, that it's worthwhile understanding maybe the manufacturer's instructions, because new fire alarm panels, I can tell you now for one, in manufacturer's instructions are recommending surge protection on new equipment. Why? Because they're updating their data, selling more modern electronics, etc., etc. So it's worthwhile. Again, I mean, this is for me, it's a C2 because again, my experience, my logic and reasoning of the infrastructure I work in. But C3, again, from the guys who chose C3, I can see why they would do that. This is about emerging, developing, growing our knowledge and our application, but more importantly, reminding the inspector of thinking the bigger picture. because a lot of guys who do inspections sometimes can be so monotonous. These webinars are trying to make us just refocus what we would normally think about in maybe a slightly different way.
The problem, sometimes the problem is, especially like with now we've got the code breaker as well. A lot of us wanting to write a regulation down with an observation and things like that. You know, when we start to think about obviously the criticality of the equipment and stuff, we have to look at safety services, but we won't find the wording specific for what we see. We have to interpret it differently. Or we can just go to, obviously, read 5266 or 5839.
Or we can read 1311 and says the requirements are intended to provide for the safety of persons, livestock and property against dangers and damage which might arise in the reasonable use of an electrical installation. Searches are very reasonable. Fundamental principles.
Yeah, but that's not joining the dots to a fire alarm panel to a lot of people.
Well, yeah, we could hop, skip
That's
and
the
jump
point.
all the way through. Maybe that's something we probably need to do in a future one. But yeah, next one. Emergency lighting. Get the poll up. What does everyone think?
What's the question?
The question is if you have emergency lighting within the premises and there is no surge protection at all, as on fires, what would you code it? Told you we're going to be slightly controversial in this one. Let's push the old grey matter a bit.
My favourite way to be, a little bit controversial.
Well, no, just I think challenging and asking questions, because for me, if I can be honest about it, in the last 2-3 years, I think, Dave, we've been doing this. We've been asking more questions and getting the answers we wanted, and then having to go and find the answers ourselves.
Yes, I may have been doing some of that myself. Yeah, questioning things and poking.
Yeah,
annoy me.
Well, I find it embarrassing, and I'm going to say this out loud, that we had to fly to friggin' Vienna to speak to an AFDD manufacturer because the information we were getting from the industry was pants. That to me is an embarrassment.
Well, the industry didn't have a clue, to be fair.
No, they didn't. But that's fine. You know, I'm not paid to do this as my day job, by the way. This is me doing voluntary stuff.
Just waiting for a couple more people to vote. 75%.
Dawn's just been controversial.
Is he?
Being lazy. It's a limb for me. Typical Sean. Yeah, it's a limb. I'm tired.
It's interesting because you've just read out 131 and people have gone C3 with this. This is C3, 50%, C2, 41.
Yeah,
So I'd say,
on that.
if you were, I'd imagine this as if you were installing a new panel and it was under 18th edition and it had a circuit on it feeding emergency lighting. Straight away in my mind, an emergency lighting circuit is a life safety circuit. That's what it's designed for. So if you were installing a new board and it had an emergency lighting circuit on it, that new board should have surge protection on it under 18th edition. But when you're coding it, you're not coding to current regs. If I'm right in this, obviously I'm not an electrician, you are coding to wherever that was installed. So even though it's a life safety circuit, there is an argument for either way, C2, C3.
Yeah. Well, you go to current regs, but we don't retrospective. We have to consider retrospectiveness. So, I mean, as Paul read out, was it 131.1 something?
0.
Yeah. You translate that the same here in that the system should...
It's the first line in fundamental protection for safety, fundamental
You
principles.
love
Chapter
part
13.
1, though, don't you? You
Chapter
never leave
13,
part 1.
I tell you now, if you just love it and hold it close to your chest, you'll never go wrong, because it gets rid of all the politics and all the opinions of the arguments. Does my protective measure meet the fundamental principles?
Again, it's a case of what if. Now, what if there's an overvoltage and now your emergency lighting doesn't work? Yeah, I put it on Twitter just last week where there was an incident where a gentleman obviously was found at the bottom of a emergency escape, and the emergency lighting, I don't know what the exact details was, we don't know, but a prosecution happened and the emergency lighting maintenance was the prosecution. So clearly, investigations concluded there was inadequate lighting.
Mark Holmes said Type 3 at every standalone fitting. It'd be really interesting if the plug and socket manufacturers could build a Type 3 into their devices. That would be quite a little coup, whoever does plug and socket, you know, like the click systems and stuff. If you get the emergency ones that are red, wouldn't it be really cool if the emergency ones actually had surge protection device built into them?
That's a good point, though. I mean, with a lot of the times we're not installing centralized systems these days. We're going for these local maintained, non-maintained fittings. Do we need to consider protection at every incident?
A couple
If
of
we
other
step up to
comments there.
SPD protection.
Adam H has put C3 depends if new LED units or existing old units, presumably the old ones with the fluorescent 8-watt tubes.
8-watt tubes.
And then
Completely agree.
C3, as Rich Harrison said this, C3 batteries will kick in and leave the safe escape for people. Well, are you sure? Because if a surge or transits come in and damage the electronics in the unit, who's to say that it's actually going to work anymore, whether it's on batteries or not? So that all depends
May
on
not
the
be
internal
charging
design
anymore.
of the thing, because say if it's an old one that's got a linear power supply, then it might be that the actual battery part is totally separate from the mains that comes in. But a lot of the new ones, it's all one circuit board, and if something gets damaged on it, it may not work on battery or on the main. So it's certainly not guaranteed to just work on battery regardless.
Just to give you a little bit of an update, 560.9 is there's a comment on emergency lighting about it complying with the requirements of 5266.
Yeah.
And BSEN 1838. BSEN 1838 hasn't been updated since 2013. They're generally pretty pants, to be honest with you, standards, because emergency lighting is about minimalism because of the associated cost. Because of that and the inherent dirty part of this, the way I explain emergency lighting is imagine the entire supply chain of electrical contracting, the arse end of everything. The last thing is the emergency lighting. It's like the poor cousin of every part of the electrical contracting.
It definitely sounds like you're speaking from experience.
I am speaking from electrical experience, and I've done lectures on this because it just annoys the hell out of me. But yeah, so it's always the poor man's cousin, really, as far as consideration, never mind surge protection. For me, it would be a C2 if it's commercial, industrial, or anything public. I can see where people use the C3 because we, as an industry, as a group of inspectors, we don't have these debates and conversations. However, I think it's on our Instagram, a recent incident of an overvoltage where the ballasts for the old fluorescents would swell and they would basically cook and the components would burst out of their shell and emit black smoke. And I've recently had an incident where that occurred, and we put that down to overvoltage.
I remember well over 10 years ago when I was replacing a load of ballasts for Tridonic electronic ones. So electronic ballasts have been out for a long time.
Yeah, they have. People have always hesitantly gone towards LED until the mad sales pitch of every LED company out there, and now we've just got this chaos when it comes to lighting and switching and what systems to use, whereas it was just bulbs and switches before.
I guess the challenge is understanding how you then apply this protection.
What did everyone come up on?
People came up with C3, but how would you apply this protection to an emergency lighting system?
Depends on the system, isn't it? And again, it's the what protective measures are you applying? So do you have a static inverter? Is it central UPS? Is it self-contained?
Well, those systems are easy because you've got a suitable wiring system. You can put the protection at that point. But the majority of the time, we're putting them local systems, little self-contained luminaires, and that protection is all there.
Yeah. But if you're doing a central UPS, Dave, and there's a switching mechanism from the UPS, because there's a loss on the DNO, that switching isn't surge one of the biggest causes of internal surges from internal switching. Well,
80%.
Yeah, so an internal UPS switching, which I'm sure lots of companies do regularly, but that could cause a surge. So have we considered it? Probably not in the past, Steve. So is it something we might want to recommend? So I can see where the C3s have come from. It's an interesting one. It's a good debate to have.
We don't have answers. We have problems. That's what we do.
We have problems.
Yeah. That's so we should have said that at the beginning, really.
Yeah, we have just nothing but problems. Dear industry, please don't hate us. So this is a little slide and a picture. Sorry about the quality of it, but it's a really good picture because it kind of explains. Just for electricians, BSEN 62305 Part 1, Protection Against Lightning. That is the document that actually defines a lightning strike. And what I will tell you now is in the definitions or in section 3.8. It says point of strike, which is a point where a lightning flash strikes the earth or protruding object, structure LPS. So the lightning strike term is actually point of strike now because these standards grow, and the term stroke is also in the standard. If I can...
is that now point of stroke?
Yeah. Hang on. Point of strike. Well, actually, there is a lightning stroke, which is a single electrical discharge in a lightning flash to earth. So for electricians everywhere, this is how we very cleverly say it: is strike 62305. If I can get this to work. Stroke 7671. Now the difference is this is Sean's house over in Shoebury-Ness. And what you've got is a lightning strike with lots of branches and stuff hitting a tree, and the stroke is basically the after effect of that lightning going into the ground and effectively appearing on cables that could be running in parallel or underground, etc., and how that then conducts into the installation. And that the standard that deals with that is 7671, unless Kirsty's going to say, shut up, Paul, you're an idiot. But that's kind of the way I've always explained it to electricians. So strike 62305, stroke 7671. That's kind of how I've
kind of always thought of it as strike as the delivery of the energy to ground, and stroke as the transferring of the energy in the network.
Yes, basically.
That makes sense.
But just to throw more chaos on that fire, 62305 does define short strokes and long strokes.
Oh, great.
I know, and multiple strokes and all sorts. So
gentle strokes and different strokes.
Yes, strokes indeed. But yeah, so that's kind of the easiest layman way of putting it, really. It's the after effect of that non-direct strike, which we're trying to deal with. Atmospheric origin stuff that can have a cumulative effect outside the installation and rise potentials within it in a hazardous way.
That's it. So how I explain that when I'm doing my seminars is if you imagine a puddle and a raindrop going into the middle of a puddle, and then you have this ripple effect coming off, that's exactly the same thing you get from a lightning stroke. So when the lightning hits the air, hits it, you get these rippling off exactly the same as you would in a raindrop hitting a puddle, except they travel much further. You get up to 2 miles from the center of a strike. That house there would have a lot of damage. An awful lot.
We need to issue a severe apology to everyone listening, because the guys in the chat room have asked the most important question, and that is, what about Thor, the god of thunder? How are we mitigating Thor?
He's the god of thunder. He's not the god of strokes.
No, yes, God, yes, damn you, yes. Bang on. Thor does what Thor wants. There you go. We've answered that question. So there you go.
That's a good analogy there, because
it's a great analysis.
The puddle.
Yeah. So that's kind of it, really. That's where
my training's full of them. I love an analogy.
Yeah, great.
Analogies are good. That's it, really. If there's any questions or anything else,
there are.
We'd try and be different in this one.
There's quite a few questions. There's just one in the chat from Richard Harrison that says, so things like disabled WC alarms, tannoys, PA systems may need surge protection as well. And yes, they may. Depends on what their function is. So if you've got a PA system that's there to give emergency announcements, such as evacuate the shopping centre, then yes, it should have, because obviously if that was broken and then there's emergency, well, you can't get the people out of there. So
some tannoys are used for special reasons and special code words. If there's a bomb scare, there'll be a tannoy allowed, out to staff. And, I remember once I was in London Aquarium, and over tannoy had Mr. Fish come to reception. I said to my wife, something's going on here.
Yeah,
15 minutes later, we were evacuated. So yeah, those systems, if they're used for any purpose like that or evacuation, then definitely.
I'm struggling to find where the questions are. I'm going bonkers evidently.
Go to
my screen's appears different.
QA. I'll read the first one.
I've got it.
Yeah, David.
Oh no, I've lost it.
Right, 514 has lots of labels for all sorts of things, but nothing for SPD. So do we think there is any need for a type of label or any kind of labeling to help with SPDs?
Watch this space. Amendment 2 is on the way. Watch this space.
I'm going to edit that out now.
Also, if it's not in BSSM, it doesn't stop you making your own labels for things.
No, it doesn't. It doesn't stop you making your own.
Work from the regulations, not to them.
Okay.
It's right. You don't need to edit that out, Paul. That's absolutely fine.
Okay, cool.
Right. Another one from David. Other influences from services outside BS 767, such as BT overhead cabling, would they require SPD type 1s or aerial installations, Virgin Media, etc.?
Yeah.
If you imagine it, you're creating, if you imagine your house, or the house you're working on is a bubble, anything that comes inside your bubble can bring problems with it. So yes, you can protect your BT phone lines, you can protect your broadband, you can protect your aerials, you can protect all these sort of things. And they do talk about them in 7671, but there is no regulation specifically saying you have to do it. These devices are out there, but there's nothing to say you have to do it.
Good part of the question, though, Virgin Media, etc. Who's responsible for it? So if the electrician recommends it, can the electrician then be fitting onto the Virgin Media cables?
If it's Virgin, then no, you can't, because Virgin are really hot on people tampering with their equipment.
Mm-hmm.
Even if you just unplug the box, they might actually come around and see what you're doing. And
Really?
So how could we
I'm in
isolate? How could we isolate Virgin from the rest of the property if we can't protect Virgin?
Mm.
That is a good question. I don't think you can. It's going to be up to them, because say their network is monitored extensively, and if you literally unplug things or do stuff, they will know, and they could actually just pop round and see what you've been doing. Naughty. The other point in that questionnaire says, is it an SPD type 1? And it's not, is it?
No.
For that situation.
No, not in that situation.
Although it's an overhead wire, it's not the same as your overhead wire for your power coming into your house. It's a type 3 there.
Type 3, yeah. Or you can save yourself a lot of aggro and just get the BT cable removed off your house, like I did when I moved in. Because I'm a Virgin Media, it comes up under the ground, and I just said to BT, I don't want that wire anymore, and yeah, there you go.
Yeah. I'm actually not looking at the chat in case people are talking about these questions as we go through them.
Lost the chat now, anyway.
Check.
Okay, Old Father Watts, could it be argued that Reg 443.4 protection against overvoltage shall be provided where the consequences caused by overvoltage could 1. Result in serious injury, 2. Loss of human life? Looking at Paul's photo, there is definitely a fire risk. He's always on the fire risk. Possible explosion risk, etc., which is a risk of injury life. So regardless of any other issue, cost, etc., we should be installing them. This makes the absence of SPDs a C2 dangerous under fault in all domestic installations. At least
we've got that right in, though, to say that for domestic installations they may be omitted. Unfortunately, that is what it says for single dwelling units. Unfortunately,
it's stupid.
So Old Father Watts is basically speaking from the experience of fire service and houses and fires catching while people are asleep.
And I completely agree with him.
I remember hearing, I can't remember who it was I heard. I remember someone debating this, and there was a similar argument in this. And I think the person said, in your home, you know your escape. But if you're in a hotel, then you're unfamiliar. I don't agree with that. But I remember someone else.
That.
I remember someone else saying that. I don't know where it was. But this domestic thing does create a huge amount of frustration.
I think I remember that. Yeah, I remember that debate happened. I remember we were kind of giggling and chuckling to ourselves. I
don't know who said it.
I do. I'm not saying it.
Oh, okay. I don't. But no. Fire. Yeah. If Paul's mentioned there's a risk of ignition. If the absence of SPDs can result in a risk of fire, then yeah, Father Watts is going to be immediately on that, saying, well, if there's a risk of fire in the home, then it's dangerous. It's potentially dangerous. It's a C2.
No, I completely agree. Especially the thing is, you could have an overhead line feeding a domestic, and they still class it under a domestic reg. It's still under a single dwelling. So whether it's overground, where you could potentially hit a direct lightning strike, or underground, they still classify it in the same regulation, which I don't feel it should be.
You know what I'd love to see with all these questions? I would love to see an event and a seminar where the ECA, they're the same thing, NIC and ECA nap it, and everybody sits down and nobody leaves until we have these debates, and we have a good old-fashioned...
They've already agreed to align before the meeting takes place, Paul.
Oh, I'll shut up. Yeah, good point.
You know, we know this.
Good point. Yeah, right.
To align, or you can't come and play.
Yeah, that's true. That's true. Yes.
All right, yeah. So I agree with what Old Father Watts is saying, but it's the same as the fire premature collapse thing, which people probably have seen the argument for that. Unfortunately, we know nothing. What with his 20 years experience running a fire station, he has no idea. Right, Richard. Hi, Kirsty. Hope you're well. Good to have you on tonight. Is it okay to send me
Lovely to hear.
some info on Surge? when to fit, what type, etc. In terms of when to fit, it just undertaking minor works. We fit them as standard on big new installs and major return work.
Hey, Dave, what are you doing with the accent?
However, we're just
on?
adding. This is my reading from someone else's perspective voice. I can't do.
Oh,
I
see.
can't. I
Right,
can't
okay.
do Paul's Liam Neeson. However, when just adding new circuits or adding or altering existing circuits, do we fit them? There's a question.
Okay, so first things, if anyone wants any more information, the best thing to do is to either contact me through my email. You can email me, Kirsty at surgedevices.co.uk, or if you go onto our website, I hold all the training webinars on there. There's a training section. I hold lots of different webinars personally, so you can contact me exactly that way. Anyway, I can get on to do some training with you. In terms, I forgot the last bit of the question now.
Just adding new circuits, adding and altering existing. Do we have to fit them if we're just adding minor things?
So that depends on your school of thought, to be quite honest. In terms of the regs, it would be the wording is if you make a significant amendment, if I believe. So it would depend what you were doing. If you were giving out a certificate, say your board was to 18th edition, your work was to 18th edition, then really if any of the circuits fall under 443, we should be putting surge protection in. If you're not saying your work is compliant to 2008, the regs 2018, then I'm into it.
Yeah.
Unfortunately, again, it's open.
It's open to interpretation.
Yeah, really, it comes down to what you're doing, and it's the same as everything else. If you go into someone's house, say to just replace a light switch, not desperately likely going to start recommending surge protection and all the rest of it installed. But on the other hand, if you're going there to sort of rewire half their kitchen and do the rest of it, well, yeah, you probably should be, because obviously making fairly large changes and alterations to that stuff. So it's really along the same lines as any other work you're doing. To say, if you went to a house, changed light switch, if that circuit didn't have RCD protection, you're not going to say to the customer, oh, well, here's your light switch for £1, and we're going to have to put a whole new consumer in and then start rewiring the house just for that. So common sense applies, I think, there. So assuming people have such things.
Common sense is not common and sometimes not sensible for a lot of people. I agree.
David said earlier, are there any DC-based SPDs, or does it not matter? They do both. Paul, you've got experience with DC SPDs. Do you want to?
I've been using ones that were specifically designed for DC that are pretty new to the market, actually, in fairness. We've only installed them in the last 6 months, and they are specific just for DC solar currents. They're designed specifically for PV applications, because it's not a chopped AC waveform. It's a pure DC,
Smooth DC.
Smooth DC, indeed.
DC. Is this like Surge do, Kirsty?
Yeah, so we've done them for years. I mean, any surge device will have a DC current. It always will be lower than the AC current rating, but it will have a DC current rating. It's not usually advertised on most of the data sheets because most people are using them for a application anyway, but then there is some DC specific devices, because obviously we go down to a lot smaller voltage when we're doing 48 volt, 30 volt, things like that. So we do have specific ones, and then you have your PV, and then we have all wind turbine ones, and there's thousands of different applications. But yeah, most normal surge devices will work on AC and DC, but obviously they'll have different levels of what they'll do for both.
Yeah, I think the voltage thing there is important, because certainly for solar panels, the actual DC voltage there can be extremely high, even in normal operation, sort of many hundreds of volts. So obviously you need to make sure the device you're fitting is suitable for whatever the actual panel array of voltage actually is. So otherwise,
that's it. Our two PV devices, we have a PV 600 for a 600 volt system and a 1000 volt for a 1000 volt system. And then we got in type 1 or type 2, depending on if you've got LPS on the building. So there's different considerations you've got to think all the time with them.
Adam says, good evening, Kirsty. When I did my 2391 at Premier Training, or Premier, I assume that's NAPIT's training, I think.
Yeah.
They gave me a handout by yourselves for the type of surge and where to fit them and the product you guys offer. So have you given some handout materials to NAPIT's training business?
Yeah, I've done quite a lot of work with NAPIT. I appear on all their, for the last few years actually, any of their sort of events, I've sort of been there and been involved. I've done a lot of their panel work. I'm their sort of technical person. I still get phone calls now, and it's, oh, I've spoken to NAPIT Technical and they didn't know the answer, so they give me your number, and it happens. So yeah, they have got some of my information that quite possibly could be given out.
Do you have other kind of packages or resources that you can give to other colleges, or some kind of kit?
So it's just our brochure. So I've got a page in our brochure that sort of takes through a simple working out what surge device you need that covers most scenarios. So I can always send that out. I have dropped my info into the chat, so my email address and my phone number. So if anyone wants anything like that, just drop me an email or give me a call, and I'm quite happy to help.
We'll put it on the YouTube video comments as well below.
Thank you.
In the
Yeah,
information.
Awesome. Dean says, what type SPD for external equipment on roofs fed from local DBs?
So there's two things we need to think about here. So firstly, has the building got a lightning protection system? Because if it has, then anything that's on the roof will be cross-bonded to the LPS system, at which point, if it's cross-bonded, we need a type 1. If there's no lightning protection system, then we go type 2.
Yeah, short and sweet. That's good.
Simple answer to a rather complex situation, wasn't it?
Yeah, it was pretty good. Dean then says, what reg can you use for fitting SPDs on life systems?
4.3.4.
Sorry?
That's a very short
What reg was that?
443.4.
There we go, 443.4.
763.4.
That's the 4 points, isn't it?
Yeah,
Yeah.
life safety circuit.
Yeah, cool. There you go, use that one. Alrighty, go. William. Oh, hi, William. Sorry to see you, sir. Is there a device to protect incoming telephone lines?
Yep. There's thousands of surge devices that do all different types
Type
of
3
things.
device, isn't it?
Yeah.
Does it fit in line with it then or something?
Yeah, so most type 3 devices will be more that they'll sit in line specifically. And so if you think of them then as acting sort of like a filter type thing of not letting the surge through.
Okay.
Oh, I've just seen somebody, write in the chat about Premier training in Oldham. Is that Daniel? Daniel Casey? Yeah, Daniel, if you're local to Oldham, that's where my office is. So if you ever want any training, let me know, because I can probably train you a little bit better than Premier training on surge protection.
She's local.
There you go. I'm local.
Yeah. David says, what sort of cost and days to undergo training? I'm booked already on a 1 day at the moment in October. Contact Kirsty. Don't know what training you're on about.
Premier training, I have no idea what their costs are. That's probably something crazy, because that's what training organisations rather tend to do. But if you ever want any training on surge protection, I mean, I give out free webinars. I'm doing them several times a week. If you want, there's lots online. If you want them on something specific, drop me an email. I can design something specific. That's not a problem. I'll do all that for free.
My recommendation.
Education is
my recommendation is not to look at training solutions in this kind of area. Look more at what the manufacturers are already providing, because most of the times the training solution will be created by them, offered by them, or a very badly filtered version of what they are providing for free. To be fair. The only thing you obviously may want to seek is some practical experience of installing. That might help. That's about it, really. I think I know a lot of guys lack experience in that. Okay, and we have here... Oh, Rich has carried on the other one from earlier about new circuits or small. Yes, I'm saying just a few new circuits. Our new circuits are wired to the 18th, but does the installation warrant SPD, or is it just a major refurbishment? Well, I mean, for me, if I'm installing a circuit, then that's an installation certificate, and I've got to consider protection against over voltage as much as I've got to consider protection against over current and electric shock and thermal effects. So 4.4 comes in play with my design of my new circuit, even if it is one circuit in an existing installation. If I'm designing to the 18th edition, then it comes in. I don't know what you guys think about that.
I think 13216. Which again, no alteration or addition, temporary or permanent, shall be made to the existing installation till it's been ascertained the rating and condition of any existing equipment,
He refuses to
including
leave
that
part
of the
one.
distributor, will be adequate for the altered circumstances. Furthermore, the earthing and bonding, if necessary for protective measures, shall be adequate.
No, if Paul Miner ever ended up in a JPL committee after about 3 years of disagreements, the regs would end up about 4 pages long, because it would just be part one. It'd just be
13
part one.
fundamental principles. Do you know
Just
what?
chapter
I've worked
13.
in too many companies where you go in and you go full on. Here's 5,000 snags, loads of technical babble, and then you'll go to a board of directors and they'll go, Yeah, just Janet and John it for me, please. It's just simple layman language. Basically, don't meet the
You
fundamental.
go back to part 1.
Oh, okay, right. So if they haven't met the first 6 pages of the book, why are you arguing about the rest of it? Oh, yeah, good point.
All right, so those questions are answered. All right, anything else, guys, in the chat? Okay.
I'll just say that Premier Training is now NAPIT Training. They've ditched the Premier Training name completely now.
They were NAPIT, then they were Premier, now they're NAPIT again.
Yeah, it's NAPIT now. Who knows what the future may hold? But they've changed their whole website and everything to that now. So anyway, it's the same place. So, and they've owned it for years.
You actually did you do training with them recently, John? Didn't you?
Yeah, for the EV course. So.
Yeah.
Paul Brewerton has asked, what is JPEL again? Well, not again. It's the Joint Power and Electrical Committee. We'll do a video on it at some point.
Yeah.
So it's the committee it's the committee that writes the wiring regulations. So basically we look at all the European and harmonized documents and all the regulations from everywhere else, and we condense them down into UK suitable regulations. So we write the S7671 essentially. I say we as in I am a little very, I think it's split up into 4 sections. You have A, B, C and D. I sit on D, and it's different parts of the book fall in different sections. There's about 30 to 40 people on each panel, and then you have JPEL as in the total top, the JPEL 64, and they basically review everything that the other panels have done to bring it all together.
But this can sometimes excuse why the things are written differently in one area of the book to another if one committee's decided to write it that way, and creating a standardized normally works well, but sometimes it doesn't work. And when you read other standards by people that are also involved in JPEL, you can see a complete difference. We were in a stand the other day and the word basically was written in it.
That's right, yeah.
You know, it's like basic. I'm like, the word basically is in a British standard. I'm like, hang on, who's
BSCN 50122. And it also appears in BS 7430 as well, basically.
Basically. Oh, basically. Like, oh, okay.
Basically? Really? Who wrote this?
So,
David Betteridge has put, where did I go for that training course? That was in Bournemouth. They did it in a hotel over 2 days. So
the EV?
Yes.
How did they do the practical?
They had test rigs that were wheeled in on a trolley, plugged into an isolating transformer and a load of other gubbins, which, as you can imagine, doing things like loop impedance tests gave rather strange results. To say
yeah.
But yes. Anyway, it sort of kind of worked, but yeah, not ideal. But obviously, no.
Rich, I just want to respond to this quick. I meant we fit an SPD to an existing DB. We've come off for a new lighting circuit. This would mean we need to fit an SPD at the origin, the subboard. We've come off in the SPD. So you're going way back. You don't need to go all the way back through your installation. You need to consider your new installation. So irrelevant to how many panels are in this board, this installation or whatever, if you're working from a sub, you're putting a new circuit into that sub, you would only need to surge protect your work. So you would only actually need to do it at the sub. You wouldn't then need to go back to the origin because that's not in your scope of works. And so you'd only need to look at putting in surge protection in that sub distribution board that you're taking your circuit from.
It's a bit like when you work out your loop impedances, you have to add it to the ZS at DB. You work from that board. And when you do a design, you're working from that board and you install the protection at the board, which is the source of energy to your work. You don't have to go back and upgrade the whole freaking factory. Just protect your work. Unless they want it.
At the uni where... Well, exactly. You can go and recommend it. There's no reason you can't. I think Richard here is working from a background where he's working on universities, and he says we'll end up putting them on everything. And to be quite honest, in a bit university situation, you probably are going to be putting them on most boards. Usually universities have lightning protection systems. You'll have a tight one at your origin. Your boards will all feed something that comes off 443.4. So if at any point you are making amendments to them boards, or additions to them boards, or you're putting in a new board, you are going to have to put surge protection in it. You don't have to do it all at the same time, but as you work through the installation, you will probably have to, yes.
I think it's also, if I can be fair and balanced here and also state that the other manufacturers who've been on our podcast with them, Dane, are, I believe, soon to open an academy where they're going to cover, they're actually going to offer lightning protection specific training, which should be good for electricians, and then also Surge Protection, I believe they're developing a portfolio of training as well, which I think can only be good for anybody who wants to increase their knowledge in an area which is desperately needing to increase its knowledge. So,
Richard says, even just adding a single circuit, I've been told just add SPDs when doing major works. What defines that then? What, how do you decide if your work is major or not? I mean, we know we have a minor work cert, we have an installation cert, but how do we decide if work is major?
balance of cost and
In
risk.
terms of it being short-sighted in terms of the whole installation, I agree it completely is. But if you're working on a big installation, a big industrial installation, to say for argument's sake, and you are putting in one new board, that board might need surge protection, but that does not mean your client then wants you to go and look at the rest of the installation. So although yes, it might be a little bit short-sighted in the whole installation, the regs, you haven't got the scope of works to look at the whole installation, so you're doing the best that you can, type thing.
Yeah.
If that
Doing
makes
what's
sense.
reasonably practicable, I think, is the phrase used in law.
Yeah, I mean, the main thing is that whatever you're installing needs to comply. If the rest of the installation doesn't, well, the rest of the installation doesn't. But obviously, that's not something you're dealing with. So, although you can recommend it could be looked at, it's certainly not something you need to deal with at the time. Just make sure that what you're fitting, obviously, is meeting the requirements.
Just remember the terminology that we've been talking about: duty of care, discharging, taking reasonable steps under EAWR 29. If you've got a bag of shit installation and you're doing some work to it and you can see the rest needs improving, ensure the wording and grammar of your recommendations are strong and robust to ensure you're not sat in front of a judge one day.
New question come in before we finish. Mark says, if a T1 cannot be installed, or a Type 1 cannot be installed within 500 mil of the origin on a domestic with an overhead supply due to, say, a switch fuse in the DNO meter box or something, and the DB is over 10 meters away, is it okay to fit a Type 1 at the DB if it has to be fitted at the origin? Cost and aesthetics may rule to Type 1.
That's a bloody good question.
So firstly, never ever put a Type 1 inside a consumer unit. Never ever. I mean, these things are designed to take a direct lightning strike and live through it. You do not want that anywhere near your. You want to stop the lightning before it gets there.
They're going to let through a lot of energy.
They are. This whole thing about the origin, we need to backtrack a little bit, because we just want to get it before it gets to your circuits. So for me, how I always suggest a Type 1 is installed in a domestic circumstance is generally from Henley blocks. So have your normal feed coming up to your Henley blocks. From your Henley blocks, have a feed going up to your consumer unit, have a parallel feed going off to an enclosure with your overcurrent and your surge device in, your Type 1 surge. So just keep the cable from at that point, you would make your cable, you've got up to a meter, half a meter to a meter. You take your measurement from your Henley through to your overcurrent, from your overcurrent to your surge device, and then from your surge device to your earth. Again, that can be a local earth in the enclosure, that can just be earth to the enclosure. So that's the distance you need to keep under a meter. It's not from your meter, your electrical meter that you've got outside possibly. It's from where you split from your feed is where you start measuring, not from where it comes into your installation, if that makes sense.
Okay, I think I was getting where Mark was coming from here, because a lot of houses, as we discussed in last week's one, where the DNO have meter boxes on the outside of buildings now because of that coroner's ruling. So now all new builds have got it, and if you do have a TT wire, that's going to come down into that box. Those boxes shouldn't be used for anything but isolators, and then what normally happens is you'll get a set of 25 mil tails, which will then go all the way through the cavities and into the board. I think it was more the question was of where is the best place to arrest with a Type 1, because he can't do it in the meter box because there's no space. Does he do it in a cabinet next to the meter box and some Henley blocks, which I would probably recommend, rather than putting something at the board? Yeah. And that's where my brain, as you were talking, was saying I would probably looking at get an IP65 box where practical, or sinking another box next to it, which meaning you need a lintel and cut the wall out and stuff, and then just punch through, connect in with some Henleys and put your Type 1 in there, which the DNOs won't give a damn about. Let's be perfectly frank. They don't care. It's not their problem. If it's a new estate and your overhead lines, it's a system designer's problem for the estate. Is there sufficient information in G12? No, of course there isn't. If it's an existing installation in Yorkshire and it's a solid stone wall, you have a problem. And the only way I can think of overcoming that is, rather than arresting it inside the building where it could have blown your walls to pieces, is put something on the wall next to it as close to the origin as.
I mean, where it comes to DNOs as well, we had the big storms we had at the beginning of this year, February. I had a client contact me, and he'd had his boiler controls blown, very, very sensitive boiler. He contacted his local friendly DNO, obviously his DNO, and they told him, well, because the power had gone down, essentially, the overhead fed, power had gone down, come back up, he had this issue. They told him he should have surge protection installed to protect his equipment inside his installation. And this was a domestic householder. And he'd literally Googled surge protection and called me for advice because he'd had no idea what it was and the fact he should be installing it. So DNOs will not have any help, will not give you any help when it comes to this sort of stuff.
I think it's fair to say that DNOs won't help many people on many things. And it's fairly evident that DNOs are doing a lot to Teflon their obligations and put it back onto the consumers, based on what we see, obviously, in anecdotes and people talking to us. And
more of our opinions on DNOs. Watch our last webinar.
Yes, watch our last webinar for more opinions on DNOs, and eventually our next one when that can happen, which may be this year, maybe next year, who knows.
Again, there's a question here asking about overcurrent protection on a type 1. Yes, any overcurrent protection, so the actual level will vary on with manufacturers. But what we have to remember is, if you imagine a building with a lightning protection system where you'd have a type 1 fitted, in that we're not looking at the lightning coming through the overcurrent protection device, we're actually looking at the lightning coming up the earth. So we're trying to stop the flashover from the LPS system, which is attached to your MET onto your live system. It's that flashover that we're trying to stop occurring. So the type 1 function in that is not coming through the overcurrent protection device. It's actually stopping the flashover happening at that end. So the overcurrent protection device, don't get too hung up on that whole thing with the type 1, the fact it's got to take a lightning strike through it, because generally it's not doing. And again, when we go back to MCBs and SPDs and surge protection devices, when we're looking at a building that's got overhead lines feeding it and we're using a type 1, again, the overcurrent protection device is completely irrelevant, because the speed of a lightning strike and how fast your type 1 is going to activate, again, it won't affect it in any way.
Lovely.
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 Is there any more?
There is. I could kind of.
No, we still need a. Sorry. Sean's just put no need for current. Yes, you still need it. I'm just saying for a type 1, lightning comes the other way generally. So lightning can come up your earth.
It's a different
when
performance.
We're looking at lightning protection.
It's a different
performance.
Different strokes, different routes.
Exactly.
Yeah.
Yeah. Always need a overcurrent protection device. Any sort of surge arrestor, you will need overcurrent protection. Yes.
Thank you, Fusebox.
The lightning is that if you've got line protection, it strikes lightning protection. That strike, or the actual current, goes into the earth, or some of it does, and then a big chunk of it also goes into your earthing system and into your electrical installation. So it's not coming from the supply as such; it's coming from the actual thing it's struck onto. So if that helps.
Yeah, hopefully. Oh. Dave Betteridge says DDCLC 6164.3.12 worth the buy.
Is it worth the buy? Yeah, it's the low voltage.
Are any of them worth the buy?
Standard? No. Don't buy it, Dave. For God's sake.
Stop buying them, Dave.
Yes.
I don't know which one that is, mate.
It's the it's basically standard for it's called low voltage surge protection devices connected to low voltage power distribution system selection and application principles.
Oh, you said it's the cheapest though. It's only 36 quid. Come on.
Yeah. Okay. Fair enough. Whatever you want.
Right, I'm going to paste in the group chat Kirsty's website to her training academy link. I do strongly suggest you guys just absorb more information and look at what she does there. Anything else we want to talk about this? It's gone 10 o'clock now.
Not on this. I just want to say that there will eventually, at some point, and I don't know when, be a fire one. an emergency lighting one. It will not be next Wednesday. There is no webinar next Wednesday. We're going to take a little break from these. There's podcasts coming out now every week.
Yes, we've got podcasts regularly now on E5, haven't we?
So we have got the emergency lighting one we're going to do. We've got a fire one we will do, and we will promise we will follow up the DNO. The DNO one will probably be later in this year, maybe early next year, depending on how many more thousands of pounds worth of test kit we need to buy to actually figure out what's going on. And
again, you can always kind of have a hint of the ongoing with this, because we share stuff on the E5 Instagram.
We do.
I mean, the test kit you were showing pictures of today with your
about 80 grand's worth.
Oh.
Yeah.
Let's not forget you've got Amendment 2 coming out that you're going to have to comment on. So
well,
yes,
there's
there's
a lot going on.
that
There's that
will be
going
the
on.
next bit. That
Yes.
will be when that comes out. We'll then have to lock ourselves away digitally and just read out to each other and then shout at each other when we've fallen asleep. And yeah, get some webinars for them as well. So. Yeah.
Well, thank you very much for having me again, guys. You know, I love working
Thanks for
with
coming,
you.
Kirsty. It's a pleasure to have you as always.
Yeah, it is absolutely. Thank you very much, guys in the chat. Anything else, you guys? You done? Second, what Daniel said. I don't know what Daniel said. Kirsty, David, Paul, and JW, you are here at 10 p.m. helping us a lot with great education and content. Thank you, absolute legends.
Peace and love, everyone.
No worries, mate. It's fine. You know, we're learning here. You know, we're all learning. We're just sharing the learning.
Just imagine if all the specialists in the electrical industry did stuff like this, how much better the electrical industry would be from a safety and a standard point of view. Like,
I'm sure. I'm not
Yeah.
not to preempt what Dave. I'm pretty sure that most of the industry has already taken every page they can from Dave's book.
Pretty much.
And
Yeah. Unfortunately, they have to be able to do it. They can have the ideas, but they've got to do it. And
not be afraid to do it either.
Yeah, a lot of people just don't want to do it. A lot of people who do it look like they're being held up at ransom in front of a camera.
Yep.
There's not a lot of passion, unfortunately, is there? People are saying, Kirsty, get in the Discord. You don't have to get in the Discord.
I don't know what Discord is.
It's just it's a secret
labyrinth.
place where these people who are interested in this stuff, they spend their spare time talking and carrying on these conversations.
It's a
and things.
debating society online.
It's all my fault.
Oh, I'd love to be involved with that.
All you got to do is you go sparkingninja.com, look under the My Ugly Mug, there's a Discord button, you'll get an invite, you just create a little login. It's supposed to be for gaming.
An app. You've got an app. You can download an app, Kirsty. I've got it on an app on my phone. So if I really want to, just see what's going on, I'll look at it and go, wow, okay, very intelligent.
It's that's the key thing. It's like a little forum online, but it's intelligent conversations, not stupid questions like what's earth bonding and things like that. It's actually
It's
proper
like free
development.
Okay.
Yeah, that's what Paul Brewerton says, and that's it.
They
should be providing this for free.
For an invite. Okay. All right, guys. Everyone's saying get on the Discord, get on the Discord. All right, guys. Thank you for coming.
Your dad's telling me don't do it, Haif, instead.
Yeah. Right. He's right. We haven't got another one of these to announce right now. So you guys can obviously pop in the Discord. Check out Kirsty's site. The link is there. If you're watching YouTube, we'll put the link down here. Anything else, guys? John, Paul?
No, I think that's covered more than we intended to anyway. And
actually,
great.
one thing, there is the Earthing E5 web podcast is out tomorrow morning for me and John. When the one you didn't turn up to because you forgot, you did part 2.
Oops.
Yeah, it's all right. Don't worry. It's so long ago now. It's so long ago.
Yeah.
I've got virtually no hair or anything in it. So yeah, there you go.
All right. Well, okay. I'm gonna hit the end button, which means we disappear. So, yes. Again, thank you, Kirsty, for coming on. And we'll do this again soon.
No problem. Thanks for having me, guys.
Bye, everybody. Bye.